Hello. Srinivas Rao, sir. Good morning, sir. Sir, may I audible
Okay.
to you?
Yeah. Are you able to hear
Yes,
me
sir.
now?
Yes, sir. Yes, sir. Yes, sir. Just turn your face a little bit right, sir. Yes, little
Okay.
bit
Yeah.
right.
Actually, I have a laptop there, so I have a
Okay.
desktop here. Give me a second. Okay.
Okay.
Is it better now?
Yes, sir. Yes, sir.
Yeah.
Better. Better, sir.
Let me know
Sir,
once when we are ready to start. Okay.
yes, sir. Yes, sir. Yes, sir. From 9:15 onward, I will introduce you, and I will take only 4 to 5 minutes, and then you will start the session, sir.
Yeah. That makes sense. Okay. That's fine. So your name, please. I could not get your name.
Naveen Kumar, sir. Naveen Kumar.
Naveen. Yeah. So Naveen, so can you help me to understand the participants? Are they from all from Andhra or they are from the different locations?
They are from the different locations, sir.
Okay.
Actually,
Okay.
it is AICT-based FDP, na? So people across different regions in India are participating in this FDP.
Oh, okay. That's fine. Yeah. No. The reason why I'm asking is if they're from Andhra, we can speak in our mother tongue, and
Yes,
people
sir.
will
Yes,
that
sir.
will help associates to understand in a better way. That's my
Yes, sir.
idea.
Yes. Okay, and each and every participant has a free tier AWS account, sir.
Okay.
Okay.
So what about the CLI? I was asking about the CLI. Did you get a chance to set up CLI?
Sir, they can use, but the previous day that speaker has shown everything with the help of GUI only. But
No, I
they can,
understand, but my idea, yeah, we can do from UI. I don't have any
yes,
problem.
sir.
But
Yes,
I
sir.
want to
With
make it more interactive and more takeaway from that, so that they
it's
are
interactive.
having good
Uh,
knowledge on that.
yes, sir. Yes,
So
I
yeah,
agree, sir. Sir, you can guide the participants that you have. It is better for us if we will use CLI instead of GUI. It will give more perfection. Okay, so
right, yeah,
participant will be ready to do that.
okay, yeah, that's okay. So we'll see. If not, we will at least plan for the next section where the
Yes, sir.
people will also have CLI available. Okay.
Of course, sir. Of course, sir.
Yeah. And do you also have a, demo account where I can use it?
Yes, sir. I have, sir.
Okay. So can you share the demo account to me?
Sir, I'm directly yes, telling my login ID and password.
So you can message me one-to-one chat, right?
Okay. I'm messaging you, sir.
Okay, yeah. You can send my name and you can send me. But for now, I will continue with my session. But this is basically for the subsequent sessions if I want to play around. Or you can send me a mail with the details. Okay,
Okay, sir.
that's also fine. For now, I am good actually. But I'm just saying.
Okay, okay, sir.
So if I want to share the screen, there is a sharing option, right?
Yes, sir. You can share the screen, sir, anytime.
Yeah, okay. Yeah. Just verifying that. Yeah, that's okay.
Continue.
Hello. Yeah, yeah. Okay. Yeah.
Now, uh, good morning, participants. It's me, Naveen. Okay. It's a great pleasure for me to introduce our speaker, who is a great application designer, application architect, solution architect, and lead developer, Mr. G. Srinivas Rao. He is going to talk to us about S3, storage type, and the CloudWatch. Participants, as of now, we all know about what is AWS. We all have AWS free tier account and are all aware about EC2, which is a resizable computing power, including both CPU and memory. In this session, we will know about S3, that is a simple storage service that refers storage in AWS. S3 is a highly scalable, durable, and distributed object storage for crucial and primary data storage. So we should all be deeply interested to learn about how data is stored or managed in AWS based on degree of frequently accessing, residency requirement, or digital preservation in an cost-effective manner. Our speaker, although having spent almost his entire career working in IT industry in places like United States, in those places, he has proved his remarkable contribution in so many projects, say order rewire, to develop microservices, KPIM identity services, to analyze, design, and develop services, service layer modules, and in eBay incorporation, and many more. If I say he is a combination of dev and ops, means he is a man who has a worthy knowledge of DevOps. I may not wrong, because he has specialized in DevOps as well as AWS. In AWS, he has specialized in S3 serverless architecture with Lambda, in NoSQL, especially in MongoDB and Cassandra, for over many years, and has contributed so many reputed projects. So participants, we all welcome to our speaker, Mr. G. Srinivas Rao. His presence in this FDP is nothing less than a blessing to us. So we are participants, we all welcome again to our speaker, Mr. G. Srinivas Rao. Now, sir, we all are heartily welcome to you to initiate this session.
Sir, please unmute your side, sir. Not hear you.
Yeah, sorry, thank you. Yeah, so thank you very much for introduction. So I am Srinivas, and I did my MTech in computer science from Institute of Electronics and Telecommunication Engineers. And I also have a master's degree in chemical engineering and chemical computation. And I started my career in 2000 as a web developer, and I worked with multiple organizations in India with Cognizant Technologies as a major contribution, and ITC Infotech UK and ITC Infotech Bangalore. And then I also worked with multiple clients like PayPal, eBay, United Healthcare. So multiple organizations I worked, and recently I am working with College Board. It is a SAT conducting exam. So it is similar to the MCET exam that we conduct in India. Similar to that, we have a SAT program for the associates who completed their 12th grade or intermediate in United States, and they want to pursue their higher education. So they will be evaluated in the similar kind of entrance test like MCET for us, and that is called SAT in United States. So for that application, I am developing application for the platform for taking the test, etc. And yeah, so I have a lot of extensive experience, and I played multiple roles within the organization, from a developer to senior developer to technical lead and a application architect, and then also worked as an integration manager. And besides my role, I also have a lot of passion in training. And so I had, when I was with Cognitive for almost 10 to 12 years, I was part of my academy where I was training the junior associates who joined the organization. And I used to train them in Java, C, C++, Java, Oracle, and some of the latest topics called microservices, Hibernate. These are the persistence layer that we use in the organization, right? So these are some of the areas that I'm very passionate about and very like contribution. So this is very useful technologies for the career also. Yeah, so coming back to this, just before getting into more details of cloud computing, so I just want to introduce quickly each one of you to understand your background. That will help me to identify some of the use cases when I'm explaining the topic. Okay, so one of you, one by one, can you maybe starting from the top to bottom, maybe you can start and introducing yourself. So just give me your name and your qualification and the reason for joining session, and what is your aspiration in your career, like what is that you are looking for. Maybe I can start with Anjali. Am I correct? Anjali Devi. Can you start introducing yourself, please? Am I audible?
Audible, sir, audible.
Yeah. Yeah, maybe if Anjali is not there, we'll move to the next person. Then I think Naveen, you introduce
Yes, sir.
yourself.
Yes, sir.
Probably, yeah.
Yes, sir. Yes,
Yeah,
sir.
maybe can you help me, like maybe Vijaya Krishna? Yeah, maybe do they have access to unmute themselves and speak?
No, sir, no. But they can use the chat box.
Yeah, okay. But can you unmute one by one and we can introduce them quickly for 5-10 minutes?
Okay, okay, sir.
Yeah,
I'm unmuting all. I am unmuting all the participants so that they can introduce themselves one by one.
Yeah.
Participants,
Good
you are
morning, sir.
unmuted.
Yeah.
Good morning, sir.
Yeah. Hi.
Yeah, this is Arna Kumari, working as assistant professor in SRK Engineering College, Bhimavaram, and presently pursuing PhD in KL University in the area of cloud computing. So that is the main reason why I have enrolled in this workshop, to gain knowledge regarding how infrastructure services are going on in AWS. This is the area I'm working on. So that is the reason I have enrolled.
Okay, nice to know about it. Yeah. Next person, please.
Thank you, sir.
Yeah, I also request you tell the qualification when you are speaking, so that will help me to gauge where you are, and so that will also give me a background, right? Yeah.
Good morning, sir. This is Saranya, working as assistant professor from the Department of Computer Science and Engineering. I'm basically working in Tamil Nadu College of Engineering, Coimbatore, sir. I've completed my MTech and currently I'm pursuing my PhD under cybersecurity domain.
Please go ahead with the next person, please. Next person, please.
Participant.
Hello.
Yeah.
Very
Please.
good morning, sir. This is Dr. Vidya Ganesan, Professor CSE Department. I'm very much interested in working real-time data stream. I'm taking the research work, real-time data by Kafka architecture, microservice from IoT with the cloud. For that, I need some support. For that, I joined here. So.
Yeah, thank you. Yeah. Next person, please.
Good morning, Mr. Srinivas Rao garu.
Hi, sir.
Am I audible, sir?
Yeah, you are audible. Please go ahead.
I am Dr. Isaac, born in the year 1972. I did actually my IBM AS400 at Bitmappers Infotech Limited at Bombay in the year 1996. Somehow I have been into this academic field. Right now I am working as a professor at KL University in the Department of Mechanical Engineering, also working as Associate Dean in the AKC department. I'm actually passionate about this, the trends taking place in the software industry. And currently I'm pursuing this data science and this artificial intelligence blockchain technology. In this regard, I am interested to know about this Amazon web server, how far the facilities that this Amazon web server is going to provide is helpful to me in this direction. This is what in simple about me. Thank you for this opportunity.
Nice meeting you, sir. Yeah. Next person, please. Yeah, if you see the participant list, I think if you can go in a sequential order, that may help us. But I think I want to. Lakshmi, Lalita, somebody can speak. Okay. Yeah. So maybe you can mute everybody, but the reason okay. So if you people are unable to introduce yourself, please go and put in a chat window. The reason why I'm asking is, so there is a diversified people here in the participants. So the reason why I'm asking is, so I would like to know the intention of the course and what is your aim to understand and why you are here. So that will give me a fair context when I'm dealing with the use cases, or I can also say some of these use cases, how the current topic is relevant and in what context people can use this these services. Okay. So that will help me to understand, say, for example, one of you tell it is cybersecurity, one associate said it is a Kafka they're using, that's very good. And then one of the professors said that he's also looking into blockchain, how blockchain can be used and what are the things that I can do on the blockchain part. And I can blockchain, if you extend the blockchain, right now, Bitcoin, blockchain, you can do data mining, you can do lot many things on the blockchain. And for working with particularly the ML or anything, we have something called like the way we have CPU, we have the GPU, the general graphical process unit, which will really help us to do particularly mitigate the multiple algorithms in parallel processing using blockchain. So this is one of the key factors right now. If you see, we have earlier we have the computers we call central process unit. Right now we have the computers with the APUs called advanced process unit, which has a capability have both. You have the CPU and GPU combination with a neural engine, which will also help you to work on the machine learning and data algorithms, and very efficient in terms of decoding or mining your Bitcoins kind of infrastructure. Yeah. So coming back, so we will, I will give some idea about microservices or the Amazon Web Services and what is the role it is playing. That will give you a better context when we are talking about why I should go for a microservice or the web services, and what are the advantages to that. Okay. Give me 1 second where I can share my screen. Okay. Yeah. Yeah. So why Amazon Web Services and what is that it is bringing to play? It is the key role, and why cloud computing is playing a key role in the current IT industry. From a legacy world, if I come and understand the legacy world, how we used to operate maybe 10 years or 20 years down the line. Say, for example, I'm working for an IT organization and I want to host a website right now. Say, and so the back end is when when I started my career in 1999 or 98, we used to go to one data center where we have servers to host it there, and we had to go there and we take our data in a CD drive or a hard disk drive. We go and copy there, and somebody from the server team will come and make one server available for us, and where we used to copy the data, and then we used to host our website. So then once we used to have 4 or 5 engineers from the security team, from the compliance team, and then from the different teams. We used to go to the on-site premises, and where we used to go and upload our files. Once the files are uploaded, and there is a database administrator who goes and verifies the database, and then it is a sequential of process where from assuming that for a organization to host a site in back in days, it used to take almost not less than a month to set up this environment. So right now, if you see the time taken for hosting a website within a fraction of 5 minutes to 10 minutes. So that's the beauty of cloud computing. So now cloud is providing a multiple services. So those services are called like platform as a service, infrastructure as a service, and you also have a computer as a service, data as a service. So you name a service, it is available for you on fly. And so there are a lot of benefits on the cloud. The one of the benefits is rapid availability, and not only that, in terms of cost, in terms of availability, in terms of scalability, in terms of making the services available, that is very rapid. And if you see Amazon, say for example, one best use case I can say, if you see the Flipkart in India or Amazon services also or India, where you want to buy a phone, the time you order a phone, say, and you are getting the phone maybe within a day or two, right? So how this infrastructure is making the phone available, from understanding the stock availability to making a placing an order, where you are also validating your credit card, and you are also validating getting the payment from the end user to the merchant, and then from there you are also coordinating with the what you call logistic departments, which are responsible for taking the order, placing the order, shipping the order, and then the shipment process happens, and then there is a delivery process, and once it is reaching, it is acknowledging back to the system, right? So there are a lot of steps in this process. So you can say, for example, down the line, if I want to open a kind of a Flipkart company, it may take ages to do that. Right now, if you want to go for a similar kind of infrastructure, within a month, I can post a website with all the logistics in place. So that is the beauty of cloud computing today. So you name a service the way some of the professors said, like he's looking into blockchain, right? So there are blockchain services from Amazon, and you name a service, the Kafka service is also available in Amazon. You name a service, that services available here. Some of the key services day in day out I work, or most of the people work, or something like these are the computer service. Maybe you people have went through the EC2 instances where I can go and spin up a server there, and at the same time the lambdas are nothing but functions. These are called micro functions or micro. So we have something called microservices, and we also have something called macro level functions. So these functions, if you see the legacy architecture or a 3-tier architecture or entire architecture, you have your at the front end call your web server or your application server. Then you have the middle layer where you have the business logic, and then you have the data layer where you have the data which is available. And besides that, in a monolithic way or in a legacy world, we used to have around 20-30 components or 50 components in one big large file, and that file is to be deployed on your application servers like Java application servers or anything which are responsible for anything. So if there is a change in one piece of code, we used to deploy all the services of 50 applications, and then we used to do a lot of testing before the application moves. Now with the microservice world, what is happening is everything is a small piece of application. Say for example, now in a typical university, say student database, right? So whatever the operations a student can do, or whatever the things that a life cycle of student will happen. Say, for example, the student is going and creating, registering to the university for a course, and then he is registering for the examination, and he's taking the examination, and he's taking the results. And in between, he is also attending the classes, he is also attending the labs, and whether he is attending or not, you want to check. So these are all the entire process that you can automate within the AWS cloud using the infrastructure. So the advantage here is the rapidness and the making the things available at a faster rate and on-demand services. So now if I am a very small lab or I have a small company, I just want to run a few servers, right? So I don't need to buy anything on fly. I just need to use these servers for a period of time. Once my work is done, I'm done, right? I don't need to pay for any of the services. So, and the other thing recently that we are working is to save the lot of cost for the organization is called something called serverless. So if you see the backend days, you have any application server called Java application server, or you have some Oracle database or anything. So a typical organization, what they do, you has to create your application server, Oracle database server. You also need to create your application server, and the application server should be running, and database server should be running, and your web server should be running, because you have the entire architecture, right? And then again, besides that, you also need to have a failover. You also need to have a the disaster recovery management, and then you need to not only failover service within the same region, you also create a one more server with a similar kind of infrastructure in a different location. So something goes wrong in that particular center, say there is a flood happening, or some emergency came, or something went wrong in that particular location. So you have a backup location where which will take care of the making the application available for the end user. So these kind of infrastructure on fly we can do within no time. So that's the benefit of the current infrastructure. So some of the key service I can say, these are the compute services where we have EC2, the elastic computing service, where you can go and create multiple instances. So the beauty here is you can go, if I want to have a Linux flavor or a Unix flavor like Ubuntu, I need a Ubuntu server, or I need a particular Oracle server, or I need something of a different flavor of Unix. I can create my own image and I can spin up my server, and the server will be available within 2 minutes of time. So that's the beauty of the EC2 EC2. And not only that, say for example, right now, for example, I can take one more example like healthcare, right? So healthcare, what happens is, say throughout my every year, I want to go for healthcare to safeguard my health. So if something goes wrong, the user can go and visit and take the services. And at the same time, during the enrollment period, everybody has to go and do that. So the enrollment period may be for a given set of people, may falling under one particular period. Say in most of the healthcare policies in US, the way it works is they do enrollment during the month of October, November. So between October and November, this is the crucial period for everybody to go and enroll their services. So your registration services should be available to enroll to my policy, right? For the healthcare policy. No, every user in United States has to go for a healthcare policy. There is no option for us. So if I want to enroll that, then my systems only during that period of time, all these come at one shot, and your massive people are coming and enrolling for these services. So at that time, I may need to spin up thousands of servers suddenly. And again, once the enrollment period is done, maybe you may have 10 or 15 people every day, other than that period, or maybe 100 people every day. So now only during that period, I may have 100 servers or 200 servers running. And for the remaining end of the entire year, I may just need 10 servers or 10, 15 servers which to manage the service. Now the advantage here is now the cloud, what it is doing is based on your requirement, I can scale up the instances, and I can also scale down the instances. And so what is the benefit? In terms of the benefits you have is enormous. One is the end user, the client who is running the service are only pay per use. They're using only the whatever the usage that you are using. The second thing is the scalability. So at a given time, a given point of time, I want to scale up the services and make it available. I can do that. I can scale the services. The scalability is coming into play. At the same time, when I don't want to these services to be down, I can bring down all the servers and make it 2 or 3 servers based on my requirement. So that is the other point of view. And if you see beyond this story, there is something called serverless architecture, where it is coming and making you happen, where you only pay for the processing time, not even for hosting your services. So you only pay for the services that you consume. For example, DynamoDB, RDS service, then you have the Lambda services. These are the functions. The functions are available on the cloud, and if you only access the function, and if the function exists only for the processing time, you are going to pay for the service. So there is a Lambda session in the subsequent flow and the subsequent module to continuation to this one. So during that Lambda, I can also show you some of the real-time examples how the Lambdas can be used and what are the better different ways that you can utilize the Lambdas in our day-to-day activity. So coming back, so maybe very quick, some of the services I want to go through. So here, if you come here, these are the compute services, and these are the governance services. And if you see, these are the container services. So when I say container services, now the difference between the EC2 instance and the container services is, in case of EC2 instances, you are all you are putting your operating system, and then you are assigning the image, and then you are running your operating system. On the top, you are running your application. So right now, if you see, there is something called Kubernetes and Docker in place, which are helping us to eliminate the operating system level. So within a Docker image, I can run a Unix kernel. On the top, I can bundle my application. With the combination of Docker and Docker Compose, I can spin up my application. Say, for example, today I want to spin up a WordPress application, and where I want to deploy my application, my personal website of a company. I can simply use the combination of MySQL web server and the RDBase MySQL server, which is a combination of 3. These are the 3 components the WordPress is built upon. And you can within no time you can create 3 or 4 Docker instances, or you can create a 1 Docker Compose, and I can spin up the service within no time. That's the benefit of it. And here in the container services, only for, again, there is a different models, pay per use, or you can use based on the consumption that you are going to use for the services. Only for the services you are going to pay the service. You are not using the services. Okay. And so these are the some of the Docker related services and Kubernetes related services where you can take the benefit. And so the advantage between the EC2 and here is that the only thing is that you are packaging your only the application, and the amount of money or the amount of price that you are paying is peanuts compared to the EC2 instances when you are running for the same application. So you can reduce your cost very drastically when you go for a container-based services compared to your EC2 instance-based services. So then we come to the storage. That today we are also talking about going to the detail of S3 service, simple storage service, which is a key service in the AWS world, where you put all your file system or data in. Most of the data is maintained in the S3 simple storage service. And similarly, we have the database services called RDBMS services. Here, the beauty of it is these RDS service and the DynamoDB service are platform as a service. So you are not going to pay anything for the instance sake. Say, for example, in case of Oracle or in case of MySQL server, I need to host my server, I need to host my database, then I need to host my data. So there are 3 or 4 components that you are going to pay. But in case of a platform as a service, yeah, I don't need to care about who is running my database, who is maintaining the data underlyingly, and what is the maintenance underlyingly. I don't care, or I don't need to pay anything for that. All I need to do is go and create my database and start my inserting my data and managing the data. That's all I need to do. And remaining the availability, the scalability, and the pay per use. So again, you are only using whatever the data or whatever the compute service that you are using. Only for that compute you are going to pay for the services. So that's the other beauty of the DynamoDB service. So these are the document. So if you have something a document-based crawling document where you need to maintain the document, so that's where the doc base come into play. Yeah, and somebody told about the Kafka streams and Kinesis. Similar to that, we also have some of the services. I don't remember out of my mind, but yeah, I will try to go through and relate some of the key areas in terms of the way. If you can send out a mail, like what are the services you are interested to go for. Few minutes I can spend on each of the services and how I can give you guidelines in that area too, so that may help you. Yeah. And so one of the, if you come to the network services, this is where if you want to host a website, that's where the Route 53 comes into play. And if you want to create your own infrastructure or a virtual private cloud, that's where you are coming into play. So these are the some of the very key services which are helpful for you in terms of deploying services, in terms of creating your virtual private network where your security comes into play, and where you are routing the services, and where you have the API gateway where you want to expose your APIs, and and then there are other services which are very helpful also. So these are some of the key services in terms of networking. And then we also have the DevOps. Basically, the DevOps is where I am going to, so if I'm a developer and I want to commit my code and I want to build a pipeline, I want to deploy the artifact on the AWS cloud, and then I have the Cloud9 for like a IDE on the cloud, and then Cloud Shell is a command line or a terminal within the cloud. So the Cloud Shell can also be accessed from here directly. So I can go and click with the Cloud Shell, and the Cloud Shell will come up and it will open a EC2 instance, and then it will also spin up my the shell terminal, and I can play with all the AWS CLI commands from directly from the Cloud Shell. So that's one of the new services they have come out with. That's a very beautiful service. And then, so these are some of the data pipelines or Athena data pipelines, which are very useful. So Athena is so when I'm storing some data on S3, I can also use Athena as a query language to pull the data from the S3 bucket. And I can also run data analytics. I can also run data pipeline. I can also transfer from one data to other data. I can also do the what do you call ETL kind of jobs I can also play. And one of the ETL tool is also Glue that you can look into. So these are very useful services for your data analytics, data reporting. This is a data reporting tool, and Kinesis is similar to the Kafka. Kinesis is a parallel service to Kafka. Yeah, so these are some of the services that are very useful for analytics and data mining also. And then we also have Internet of Things, where these days which is very popular, Internet of Things. So one of the use case I can tell of Internet of Things is that, like for example, I have a refrigerator within my house, and like that, every household has a refrigerator. Say LG has a refrigerator with a particular model, and he want to know like how the refrigerator is working. So using the IoT devices, they know the metrics, like what are the components are which are active, how many hours you are using the utilization of this particular refrigerator, and what is the utilization factor, whether it is cooling very as per the norms, or whether it's not cooling as per the norms, and what are the components it is giving the problem, whether these components have a bulk problem with all the refrigerators. So they are running the data analytics based on the different parameters and different usages. So this will help the organization to enhance the quality of the system at the end of the day. So that's one of the use cases I can think of. And one of the other use cases you can think of is, for example, right now, if I'm traveling from one location to other location, and I install a IoT device, now your family will know where are you and which is the location you are going through, and exactly, and they know, like once you reach your office, you start from a home and you go to your office, and the time you reach, it will send me an alert to the household, the spouse, saying that okay, your spouse has been reached to a destination and he's safe. So that will help us to understand what are the other different parameters that we have. And in case of emergencies, you can also bring an alerting system saying that I have an emergency and I need somebody's attention, right? Maybe healthcare needs, and if something goes wrong when you are traveling, and you have an emergency case, and then somebody has to attend you, and there is one very beautiful opportunity where you can use the IoT services for your utilization. So these are some of the services, and the workspaces are something like, okay, now many organizations now Nowadays they want so now you are giving a basic system. Now suddenly like your requirement changed and you want advanced systems, or I want to have a memory of 32 GB. I'm working, my team is working on ML, or my team is working on blockchain, and suddenly you have a requirement where I have a huge desktop requirement. I can go and spin up a desktop within no time. I can have hundreds of desktops within no time, and that's where I can work with I can create a worker instance on the cloud, which is available to my local, and then I can start working and within no time. So that's one of the very good uh, services by Amazon, where you can spin up your desktop environments here. Yeah, so and then you have the standard messaging queue, simple notification service, queue service, where you are say basically these services are helpful when you want to do some processing in a bulk level, right? So you say, for example, I have a credit card processing system, and if I want to say, if somebody is applying for a credit card, there are a lot of steps involved in credit card before the credit card received by the end user. So you need to evaluate him for say what is the what is the financial status of the associate, and whether he's earning or not, and whether he's running a business, or whether if he's spending x amount of money, whether he's capable of repaying the amount to the organization back, and whether how many days with what is the credit debit ratio, and what are the logistics he can, and what is his technical background, and you have multiple parameters. So now the queue service, what I can do is, as soon as the application is submitted, now I have to do a background verification, I have to do a financial verification, I have to do security verification, I need to do the verification with multiple units, and these are all diversified units, right? So using the simple service, I can create multiple services, and each system will receive the respective message of the user, and you are parallel. So whatever the activities that I can do parallelly, all these activities can be done in parallel way. And once every process is complete at the end of the day, okay, so this all the processes are completed now, and then I can go forward with the processing the credit card applications. So that's where you can, one thing is you can do activities in parallel, and at the same time I can also process millions of records in no time. So that's and asynchronously. I don't need to be online, or I need to be, so whenever the process A is completed and it's waiting for process B, and the process B, when the file is available for the next process, it will get triggered by the next subsequent process. Yeah. So these are some of the services which can be looked into. So those are helpful for your day-to-day needs. Yeah. Yeah. So am I going too fast or too slow? You can hold me or message me, and then I can pause. Okay. So today's session, I will come back to this today's session where we are focusing on the S3. There are a lot of ways you can understand S3. The S3 is coming to S3. It is a simple storage service. I will pause here before going to the simple storage service. Do you have any questions before moving forward, please? So Naveen, can you unmute the participants so that they can speak for a minute, for 5 minutes?
I have unmuted all the participants.
Yeah, thank you. Yeah, I see one message from the team.
Yes.
Yeah, so if nobody has questions, I will move forward with the current topic today. So give me one quick second. So we talked about the different kind of services in the Amazon AWS cloud, and coming to the specifically for the storage services, we have the S3. S3 is a simple storage service. So I have given the agenda. So this agenda will be something like this. So we'll talk about the different types of storage services that Amazon provides, and then particularly what is S3 bucket, S3, a simple storage service, and what is a bucket and objects, and what is the versioning and cross-region replication means, and what are the advantages, and the transfer acceleration. So basically, you have two regions where you have two S3 buckets and you want to copy the data from one location to other location, or you want to copy the data from on-prem to your location. This is where you are going to use transfer acceleration services. And then you also have some demo. We can go to some of the demo where we can play around the S3 bucket. And I can also tell you some of the use cases where we can play around the S3. So yeah, so then we will also talk about how to create a bucket and how to upload the objects to the bucket and how to download an object and how to copy an object and how to delete the objects. And then we can also talk about the versioning. So what are the different versions? How do you, if I have a file A or something like my professor or my boss has created a file A and the file has gone to the from department 1 to department 2. And department 2 has modified some of the data within the file, and then now I have a different version of the file, and now I want to save the same file. But when I save the file, I want to have the versioning of the file. So I want to have the versioning of the file, and then it went to the department 3, and department 3 also created something on the top of the second version. Then you also upload the same file again back to the S3 bucket. That's where you go and create the new version. So at any given point in time, say what happened at a given point in time, the department to say, I want my own version back because I have some more modifications before moving to the other departments. Then he can go and get the respective version, and then he can work on that version and he can put it back with a different version again. So that way you can also maintain the different versions for the same artifact or the same file. And then, yeah, so we can also talk about the simple storage service and the EFS service, the elastic file system. And then we also have something called SFX. SFX stands for basically this is lets your file system, whenever there is a highly standardized secure data that you cannot provide in a standard way, and you want to also provide some of the compliances like HIPAA standards. HIPAA is basically in healthcare when you have the customer information and the customer has his own healthcare needs. This information is critical and crucial because you don't want to disclose the personal information of the users and what are the problems he has, right? So this is some confidential information about the demographic information. When I say demographic information, it is about the associate details and what is his age, what is his gender, and what is his background and what kind of complication he has from in terms of healthcare and what are the services he's currently taking. All this comes under HIPAA validations. HIPAA has a compliance here. So the HIPAA is basically part of the healthcare. So one of the areas that I worked with, particularly when I work with the healthcare clients. So HIPAA is one of the key factors for in processing your healthcare needs. Yeah. So similarly, we have other ISO standards or SOC standards, which are compliance standards. So basically, when these data has to be available, there is a lot of security layers, and this has to undergo before making the data availability. So that nobody tapping your data. So that's basically making your data more secure. And then we also have the Glacier. Glacier is basically a different kind of storage system where you also have in terms of cost, in terms of availability, compared to S3, it is low availability. And that's where we go to the Glacier, where we can save some data. So this is basically historical data where you want to archive or you want to make less available, but at the on demand, you want the data to be retrieved. So some of the best examples I can give you is in the government organization. So there is a department where if a child is been born, they need to record like the child has born and they have to create a date of birth certificate or some, yeah. So then now I need to go and maintain this data, and then yeah, so I'm talking about S3 Glacier. So that's where I'm highlighting here. So that's the reason I'm not changing anything. I will come back to the actual presentation where I'm going to show you the actual services. So when I go to the services, I will go to the actual S3 console where I will show you the creating the objects in practical right now. So bear with me, and then I'm covering the theoretical part of the subject. Okay. So yeah, so this Glacier is basically is a service which is a little bit lower in cost, and then that's where you are going to use this service. And then similarly, I also have a gateway storage service. This basically so between, say for example, I have something called on-prem, and I also have something called on-cloud. Between the on-prem and on-cloud, I want to exchange the data, or I want to transfer the data, or I want to have a dedicated line where I want to pass the data in a secure way. So in all these cases, or it can be a hybrid storage where your AWS cloud services, the data on the AWS cloud, your team want to access directly, or it can be any of the reasons where you can get a dedicated gateway line where you can use this gateway for accessing the data at a better way. So basically that is for the gateway. Yeah, so yeah, so these are the different kind of services. Let me open my presentation. That will help you to give a different perspective right now. Yeah, so these are the key services. Maybe I will just recall day-to-day life. We and for the all the most of the developments, these are the key services. Some of the services we talked about. So some of the service, this is IAM, identity and access management service. This is virtual private network. This is the elastic cloud computing service, EC2 instances where you create the EC2 containers. Route 53 is for domain services where you want to post a website and where you want to register, say www.srini.com. I want to register, I can go and register and map my folder and create my web service. And that's where I also can show you a use case where in the current context, I can make my data available, or I want to publish my resume on my website, right? I can use the S3 bucket as where I can put my resume there, and I can also buy a domain and I can map the domain to this particular S3 bucket and host my site within no time. That's one of the very good use cases I can say from a S3 point of view, and as well as with a combination of routing Route 53 and this one. And okay, now and then I also want to say notify somebody. Okay, if a user is visiting to my website and I want to notify that so and so user has been visited, then I have a notification service called SNS service. And the SQS is the queue service. Basically, as I mentioned earlier, like if you want to process the large data, that's where the queue service come into play. And then we have the microservices where you micro function services. A function is a lambda. This is a micro level or macro level function where you can independently execute your code and then process your data. So this is the advantage here is if you are not using you are not paying for the hosting the lambda, you are only paying when you are consuming the lambda. So that's one of the benefits. You are only paying for the process time. You are not paying for anything else. All the data or anything is free of cost. The only thing you are going to pay is for the processing time. So that's the one of the Lambda services. Kinesis is similar to your Kafka service, and then API gateway where you host your API, you map your APIs to your function. Sorry,
sir, your slide is not visible, sir.
My slide is not visible.
Actually, from your initiation of talking, only the first slide is showing. That is static, sir.
Let me stop it and resume it again.
Yes, now it is showing, sir. Now it is visible.
Oh, okay. Okay, I'm not aware of that. Sorry for that. So I was talking about these services where we were talking about Route 53, S3, and then RDS service, DynamoDB service. DynamoDB and RDS are DynamoDB is a NoSQL database service where you can have the data in any structure. You don't need to call your normalization principles or anything, and you can directly use the DynamoDB service. And with the notification service is the SNS notification service where you want to notify somebody is coming to your site, then that's where the notification service come into play. And then we have the Lambda services and microservices where you can create your application as a single multiple functions, and each function for one particular functionality you are going to write lambdas, and then that's where you can execute the lambda and you can use the lambdas. So in the next session, I have a separate session for the lambdas where I'm going to go into the details of the lambda. And then on the lambda, say I'm managing a employee based or a student based portal. And for that student based portal, I want to provide these functions as a endpoint or APIs. Then I can map these lambdas to the API gateway, and I can make these APIs available for the end user who can consume from anywhere. Provided you have if you want to enable your security or access controls, you can use either OAuth or token based controlation mechanism for securing your API. And then CloudFormation is nothing but code as infrastructure. Basically, we have something called, it is similar to CloudFormation. We have Terraforms, one of the very famous. Terraform is one of the famous one. And other than that, within the CloudFormation, we have the different flavors of CloudFormation, where we have the CDK. We also have the serverless server. We have the serverless framework, which is a third-party provider who has come out with serverless, which is a agnostic across the what do you call different cloud providers. Like I can use serverless. So CloudFormation is specific to AWS. Now in the serverless world, I can configure my all infrastructure as a serverless file, and within the serverless file, I can specify who is my provider. I can specify whether the provider is Microsoft or Azure, Microsoft Azure or AWS or Oracle or anybody. Based on that, it will go and spin all my resources on the AWS cloud. So your resources can be a Lambda, it can be a DynamoDB table, or it can be EC2 instances where you want to spin up your resources, or it can be any of the resources that you are looking for. And for deploying all these are the code pipeline or the build pipeline process, where this is the DevOps process where you are going to use these services. So this is the services where we went and spent. These are some of the other way of looking the services between the database, storage, compute services. Yeah. So we just to elaborate on the services. These are some of the things that I think about. We will quickly move to the actual topic maybe. This is where I'll come and yeah. So here coming back to these key services, the simple overview. So this is basically the S3 is a simple storage, and it is more like very easy to use, and it always it has multiple interfaces. But somebody can use the interface using either REST, or you can use in the SOAP, or you can also access using a AWS CLI. You can also access using different ways of accessing the data. So we will, instead of going to the theory, we'll play around the stuff now, and then from there we will see how we can take it forward. Okay, give me 1 second. Let me slide, and then we can go into the actual application where you can play sometime, and then come back to go through the content again. So that way you'll give a fair idea like what I'm talking about, and it will be easy for you to understand also. Okay, so now I want everybody to log into their respective AWS console, and then I can show you one time, and then from there we can play around what are the things that we are talking about. Okay, so if I go here, these are the services. I can click on these services here, and I can say here either I can say S3, I can type S3, and I can go through the S3 simple storage service, or I can say simply I can also come here in the storage section. If I go, I can also say S3 here. Okay, so then when I click on the S3 now, right now, and then here I can create a bucket. So bucket is nothing but a container. So the container can have files here. So I can create a bucket. So I can say create bucket. So when I say create bucket, it will ask me one of the key thing I want to mention about the S3 simple storage services. It is a global service. If you see any of the other services, when I go to any of the other services, it will tell you the different zones or different availability zones where your these services are available. And again, S3 also is one of the service where based on the location, your cost of the service also varies. That is one of the key point I want to mention. So if you are using a very important data and very near, and you want to have an immediate access to that, and you want to go with the standard S3 and within the same region that where you are. But if you feel that okay, this data I want to store the data, but I want to store the data at a cheaper level. Either I can go with a different class of service, whichever we are going to see shortly, or we can also go through the different zone where the cost of the S3 will be very cheap. Again, this is also one of the service where you are using pay as you go. So if I use today if I create a S3 bucket, then I can store up to 5 TB of data, and I can create that's the limit for a one bucket or one folder. I can say technically when you within your operating system you want to create a bucket, that's where you are going to create one bucket there. Okay. So, and then I can also say what is the reason in which I am going to create the bucket. So I go with a yes, right now for now, for the demo, I can use this. And then I have the access permissions to block the public access here. So this is where one of the key example I was mentioning. So tomorrow I want to post a website. Within no time, I can create a bucket, I can unblock it, and I can make the all the access controls and make it access, and I can say acknowledge this access and make the bucket available to the public access, and that's where I can post a website and I can make it available. And there's a very beautiful use case, and within no time, within 5 minutes to 10 minutes, you can, if you know the steps, you can configure the and host a website on your using the Amazon Web Services. That is one of the beautiful feature of the Amazon. But ensure that you are very careful about the granting the permissions, because the data is also very important for you. You don't want to hack the data. So when you are going to give these permissions, you need to be very careful about what is the role that I'm going to provide and what kind of permissions I'm giving, whether I'm giving read permissions, whether I'm giving write permissions, whether I'm giving the delete permissions, what is the granularity of permission that I'm providing, or when can I go and create a custom policy. So if you people have gone through the IAM policy, then you will understand what is a custom policy and what are the different policies that I can create and how do I control the policies. So that information is a separate topic, but I will also touch base a very high level about the S3 policies when I'm going to create a IAM role for this particular activity. Then we talked about the versioning. So versioning, there's the same versioning that we follow. Like I have a file A for the same version, and I want to create one more file for the different version. Then I am going to enable versioning here. So that will enable versioning for me. And this is the tagging. Tagging basically is that, say I have one AWS account and I want to use for my entire organization, but within the organization I have multiple departments. Now say department one says I have created a one folder, and department B has created a one more folder, department C has created one more folder. But now you don't know who has created what folder and which folder is belong to whom, unless you have some mechanism to identify. And then so again, now if your departments are working, or your say within the university, you may have multiple departments, like at multiple services, like engineering services. You have within the engineering service, you have the computer service department. You may have the civil department. You may have mechanical department, right? And every department has their own funding, and so now whoever is using or consuming this service, now you want to only bill those respective departments for the whatever the use they are using. You don't want to you don't want to pay other departments, like the computer department should not pay for a civil department who is consuming this service, something like that, right? So that's where the tagging come into play. So now here what I say, when I go and do tagging, so I can say my tagging is the department type. I will give the department, and what are the other parameters, like university type is KL, and within that for each and every department, if you have any specific IDs that which are uniquely identified, I can go and add multiple key value pairs, and that's where I can identify the resource, what resource, who is using what. Okay, so then this is where okay, now okay, very good. I have created a bucket, and I can place the files here. But what if, what about security? What about encryption? I don't want to see my data with somebody else. I don't want to make it. There are some confidential documents where I don't want to openly show to all the other departments. I want to encrypt my data when I am uploading the data, and I want to have my own encryption key or a public key or a private key, which can be encrypted and I can store the data. So that also available there. You can, that way you can also secure data between the organization also. Then that's where you can go and create the account here. So then you also have something called lock mode policy, basically the read and write access. So if somebody is, if I'm writing some data, and then who can, at the same time, somebody can read the data. So how the copy is going to given or provided to the end user is based on the read write policy. So this is basically how the access policy and what is the copy instance somebody is getting. Or say for example, I am also deleting data and you are reading the data. So then you may still get the file content. That's how the Amazon is taking care, so that you also have a copy even though you are reading and writing the data. Or you can have a snapshot of copy just before write. What are the snapshot of copy that you are writing before 1 minute, 1 second before you are writing? That snapshot is given to the reading user. At the same time, the writing user will continue to write his data. So that way, your read lock policy is not conflicting. In a normal way, if somebody is writing, I do a lock mode, so that nobody can read it. And once the write process is complete, then I will release the lock and somebody can read the data. So that's a read lock mode mechanism, where you are isolating the data in such a way that the data has a consistency. At the same time, somebody is not reading the data, waiting the data before they read it again. So you are giving an opportunity to write policy to complete the writing operation. Then you are going to reading the data. So that's where the read and write policy come into play. So this is a standard way of operating system principles where you are enabling this one. So if you want to have any additional rules or anything that you want to work around the read write policy, this is one of the area that you can look into. So now I can go and create a bucket here. So bucket names, again, when I'm creating a bucket is global. If I create a bucket with Srinivas, if other bucket with same Srinivas is available, no, I cannot create a bucket. So for example, if I can create Srinivas, let me see if I can create a bucket or not. No, it's clearly saying the Srinivas name is already existing. So one other main important point I want to mention is this particular service is a global service. If I'm going to create a bucket here, nobody, and then this bucket should be global. Since it's a global service, throughout the AWS with the same name, I cannot create the same bucket. That's one thing. So that's a very important point here. So say, for example, I can say KL and I say cloud KL cloud training. Then I can say, so let us see if this is available. Okay. I'm not sure. I think it's not mentioning anything it's available or not, but let me try that. And I can also remove this for now. Let me create a bucket here. Right. So this is not available. So I'm able to go and able to create a KL cloud training folder. Now, so what are the now when you say, okay, this particular bucket has been created, very good. What else I can do with this bucket? So what are the key things that I can play around? So now if you go inside the bucket, for each bucket, this is a container, or this is a folder in your normal names, but this is called as a bucket. This is a container. And when you place a file within the container, so now I can say, I can go here and say I can upload a file here. So let us upload a file. I can put my demo file here, or the presentation that I am adding. Say I add a file. I go to my local location, and then I go to working, and I go to AWS training, and then KL, and then this is the presentation file I'm creating. So I can go here, I can select upload file, and then I can say now when I'm uploading file, if you are able to see, these are the classifications that we are getting here. So we talked about classification very briefly, but I can go over it again. So here the classification is basically about the availability of data. If you feel that data is very important and I need to have the data immediate access, then I go for the standard way of access or class type. But if you see, okay, now my data is not so important. I occasionally want the data. Maybe I want data once in a while. So I don't want to pay high cost to this data. That's where I go into intelligent tier where or a less tier where it is available after 30 days. But if you say based on the availability, based on these parameters, based on the availability, I don't even know, don't think like even after 30 days is not important. I want to go even late for a lower cost. Then I go for Glacier. Then now they have come out with multiple redundancy types. So if you want to go for archival or if you want to basically maintain for the data for the record sake, then you go for the lower, cheaper rate. And for the data that you want to frequently use, you go for the standard mechanism. That's where the different class of classification of data comes into play. So now again, so there is how this the cost is applicable for this. Now when you say the standard data will be available and based on the access permissions or based on the standard rates, you can go and calculate how much cost for that particular data access will be charged at the AWS. There is a cost page where you can go and calculate how per data per GB of data how much they are going to charge you. But if you say like, okay, now I want to reduce the cost, so you can, based on the classification type, I can go and select the appropriate type. Okay, so some of the examples I can take, again, as I mentioned, say I want to, there is an annual function every year and I want to, there is an annual function and there's some recording or event is happening, and for that event, you want to keep the data available. But you don't want to have the data for day-to-day needs, right? You hardly have the data. Maybe once in a while you want to go back and see on particular year what is the event happened, and somebody want to go through that event. Then at that particular point in time, we need to get the data. That maybe in a year you may want to access the data once in a while. So then in that case, I can go for a Glacier deep archive where I'm trying to reduce the cost. So that's where I need to decide what kind of data I'm going to use and what is the criteria or what is the scenario I'm going to use. Based on that, I can go and select the data type. Yeah, again, we talked about the encryption. You want to encrypt the data. That's where you are going to encrypt the data. And tagging is basically to differentiate the data. So I can go and upload the data now. Yeah, so if you see this data, this file, the size of the file is 87 MB. So that's where it's taking a lot of time, but we'll see here. So if you see now, now this is the bucket I have. The KL Cloud Training is the bucket name. And within the bucket name, this is the file. A file is nothing but the object. Now object, how the object is been identified or addressed, the object is being identified by key value pair. Key is the name of the file, that is the key. And the versioning is the version. So if you go into the details, once the file is uploaded in a short while, we can see what are the properties or object types that I can play around with on this particular file. And meanwhile, let me go and download some of the images. Some, I can say, photo. Yeah, some photo basically to demonstrate. So I can say I can download a photo and I can select this photo, and then I can say I want to say save this file, and then this file I want to upload it. This is the image. Okay. So now in the image, I can put the image in the download section. Say I can say baby one. Okay, now it is available for me. Then I can go back to the file. Now this file has been successfully uploaded. Meanwhile, let me also upload this other file, and we'll go back to this, and then we can upload the other file too. And I think I placed in the download section. Let me see. Yeah, so I placed in the download section. Now I have selected this file. Now if you see between the other file and this file, there is one more property called metadata. So this metadata will tell you what kind of file it is, whether it's a image file, whether it's a binary file, or whether it is a document file, or what kind of file you are uploading to the system. You can also demonstrate here. I uploaded this file. Now, if you see the differences between these files, I have the name of the file and then I have the file type. There is one more metadata and what is the time I uploaded this data and what is the size of the file, and I also have the storage class. So this is where I will identify what is the storage class for me when I am uploading the data here. So now when I go back here, what else I can do? I can copy the URI, what is the location of the file in the S3, and I can also download the file. I can also open the, and what are the other actions I can do? I can rename the object. I can say the storage type. Okay, I felt okay. Now I decided to go with the standard, but later after certain time, I want to go with the other kind of storage types. Then I can go to the other storage types and I can select the respective storage types where I'm reducing the cost. Okay, so that is one thing I can do. And then I can also add the metadata. The metadata is basically, we talked about metadata, right? So if you want to, besides this one, you want to append the metadata and add the metadata, you can also add the metadata. So metadata is something like, for example, I work for media and entertainment. So in media and entertainment, we have the file metadata called metadata file metadata. So for example, I can also show in another way. Say for example, if I go to my PC and if I go to the properties and I can show you the metadata. So metadata can be the name of the file. One is the name of the file. One is the type of the file and what is the application that it can open and what is the location where it is and what is the size of the file, when the file has been created, when the file has been modified, when who can access the file. And then again, coming to security, these are the security or ALC policies, we can say. And then we also have who is the author of the file. All this information can be available here. And then, yeah, and then we also have the other versioning and the versioning of the file, revision of the file. These are all can be a metadata, but if you want to have a custom metadata, that's where you can go and define your own custom metadata, then you have an option to do that also. Yeah. And then, yeah, so then other than that, if I can say what is the total calculation of the file, and then, okay, this is one of the beautiful feature I can say. So let me go there. Now, if we see, when I want to query some data, right, I can run an SQL command to query the data. I think I need to see if this is available or not, but in general, I need to select what is the type, UTF type or something. But yeah, you can select and then you can fetch the data. If you have some JSON file or CS file, and you want to see the content of the file, I can run queries and I can also run data analytics on the top of the file. And I can showcase the data for which is on the S3 bucket. So say for example, I can give a one scenario. Say for my university organization or with my department, I have say multiple Excel sheets or multiple reports are placed in the S3 bucket. For all the S3 bucket, how many S3 files are there for a given day? So if suppose for example you are running a lab, and for the lab you are each individual has to generate a file and upload the file. So now at the end of the day, you want to know how many files have been uploaded and whether the particular resource has uploaded the file or not. Based on that, you want to give the ranking, and then you want to automate some of the things. So I have something called S3 events. On the S3 event, you can take an action. If somebody is adding a file, who is adding the file and who is based on the name of, say as I mentioned, like in the naming convention, you can come out with a new naming convention based on the associate, and you can also say this is my naming convention, like say department 1 and department 2 and the department under and you have a batch code and you have a associate ID. So with some certain combinations, I can create a unique identifier, and using that unique identifier, I can create an event, and that event can be triggered by Lambda, and the Lambda can notify you in the database, and you can, at the end of the day, can create a report out of it. So that is one more use case you can think of. So these are some of the use cases I can say you can play around. Yeah, and so we talked about the, yeah, we can, so at the same time, I can also select the object and I can do a renaming the object, or I want to, okay, so now I have KL1. Now if I go to the top one, I have KL demo. Now I want to say, I want to only keep the images. I don't want to keep the PowerPoints here. So then I want to move this file here, right? So now I can go and move the file here. So I can say access the bucket, and then I can either browse the bucket and then see what is the bucket, or I can also go back and then copy the URI or the ARN for this one. Say I can say, give me 1 second. Yeah, I can copy the ARN. Now I can go back to the other one where I have the file, and then I can say move action, move. Here I can copy the bucket name here. Yeah, somehow I'm not able to copy, but you should be able to copy. Yeah, so you should be able to copy this file and then move file from one location to other location. Yeah, so these are the some of the operations you can play. Yeah, and then okay, so we talked about two things. So we talked about the creating bucket, we talked about the object, we have talked about the object metadata and file type. And then what we have is, if you go back to these properties, we'll see very quickly about the properties. Now, assuming that I have done some modification, now I want to enable versioning. So I have enabled versioning now. So now if I go back and say enable version, and now what happened is on this HT bucket, I have enabled the version now. So now each file that you're going to add it will create a version for you automatically. And then it will say show versions, shows the versions here. And then you can go to the specific thing and it will start versioning the number. Give me a second, I think. Yeah. So this is where your versioning comes into play. And then if you have one more version, it will keep on adding the version. So if I add with the same name now, we should be able to see the version. Let me see if I added the version or not. So let me go to the property. So I have the property and I have the versioning. So this versioning is enabled for the bucket level. So I enable the bucket. So now I go and upload the same file to the same thing again. Let me go back, and here this is my bucket, and I go and do a upload of the file again. Okay, so now if I go back to the upload of the file, and again I'm doing the same file upload now, and then I do an upload here again. Let us see what happens. So now if I go back to this file, I have the file, and now I need to I should be able to see the version now. I should be able to see the two versions now. So if you see, I initially had the version one version. Now I have the different version now. So that way I can create multiple versions of the different. Then I can also, if you don't want to maintain the version, I can delete the version, and then I can remove the particular version which is not required anymore. And then I can also go back and come. We said that I can also go to the management policies where I can create management lifecycle policies. So coming to management lifecycle policies, what exactly is the lifecycle policy means? Okay, now for example, I am uploading the file. When I'm uploading the file, I am uploading with a standard classification of class type, standard storage type, or a standard S3 type. Now tomorrow I want to say, no, I have created this file, but after 30 days, I don't want to pay on the standard rate. I don't want to pay because this after 30 days, nobody is going to care about this file, but we need to have this file in backup. But I don't want the file to be paid at a higher rate because this is after 30 days, it is not so frequently we want this file to be accessed, or it is not required for my requirement. Then I can create a lifecycle policy. Then I can say, give a rule there, rule one. And then I can say in the rule one, I can say, so what is the transition you want to do? So when I do a transition, what kind of transition or what kind of storage I want to change it to? So from the standard storage, I want to go to the intelligent storage or a one zone storage or a glacier storage, what kind of storage I want to do. So after this transition, I can say how many days this transition should be there, and when this, say I can say 30 days. After 30 days, this particular file has to move to the different kind of storage class. Why I want to do this? I want to save some money. I want to save some pricing on this. So when I create this rule, automatically after 30 days, this particular from the standard class to the other storage class, it will go. It will go to the intelligent storage where I can save some time or some amount of money there. So that's where I can bring the transition policies or the lifecycle event policies, where I can create multiple events here. Okay. So then we also talked about high level about the permissions similarly, and then we talked about metrics. Let us talk about metrics. So basically, you want to calculate how many objects you have and what is the data that you are replacing, and you can also create a data analytics out of it, where you can say who are accessing my files, how many times the files have been accessed, and when the files have been accessed, how many times the data has been retrieved, who is retrieving, and what are the why they are retrieving. So those kind of data analytics you want to do, you can also create data analytics on the top of the file system here. And these are some of the metrics you can capture. And then coming to we talked about the lifecycle policy now. Then coming to the replication rules. Replication rules is basically, we talked about something called data migration. If I go back to my MS Word document that initially I created, yeah. So the transformation acceleration policy. So this is the transformation. So I have a region one, and I want to have a copy of region from one location to other location. Now I want to replicate the data. So I want to safeguard my data so that even one copy goes away, I have the second copy. That's one criteria. And then now why you want to have second copy for a disaster and recovery. So now I have in a, say for example, my office in my head office in Hyderabad, and I also have one more office in Vijayawada. And now and you also want to have a third location for your only data security purpose. Basically, you want to store the data. Something goes wrong in Hyderabad location, or if something goes wrong in a Vijayawada location, you want to have a third location where you want to safeguard the data. So that's where I go and create a other location, other region, where I can go and create one more bucket, and between this bucket I can create a sync policy. So as soon as I create a file here in the location A, I will go and create a duplication of file automatically in the location B. Even if something goes wrong in the application A, my file is still available in the application B. That's where the this particular replication rule come into play. Then yeah, this is basically inventory configuration. It's not so important, but you can go into details about the replication policy. And then this is about the access point. So access point is nothing but we talked about, like, okay, this is where I want to make it public access, and then also I want to provide you, so make it the particular file publicly available, right? So that's where I can say, instead of blocking the file, I can say the file is available, and then now I can make the say now I have the let me go back to the files. Let us see where the files are. So these are the files I have. Now within the file I can say this file I want to make it public. So make public this one. Now I have the public document. So now I have the making this public. So I think I have to give some permissions around this. Yeah, so the block policy I need to enable. I can say edit policy, remove the block, save, and I can say confirm. Okay. Now I have given the policy now. So now I go back to the access policy and create an access point and make it public. So either I can select give me 1 second, I can select this particular file and make this particular file as public. Now, as soon as I make it public, I think now that this is the file is made as public now. So now if you go to this file, anybody on this file can be accessed publicly. So for accessing publicly, now you see the URL for the publicly accessed file. So now when I click on this, now this file can be accessed by anybody else. So that is the beauty. So now this way I can put any files within my S3 bucket, make as a website and make it publicly available right now. So that's one of the beauty of one of the use cases. You can think like I can create a public site and make the data available. Yeah, I think I'm continuously talking, but I just want to hold it for a second and check if people are able to follow me. Am I going too fast or am I going too slow? So Naveen, can you unmute the audience for some time so that we can take a feedback?
Sure, sir. All are unmuted, sir.
Yeah. Can somebody speak for me?
Yes, sir. So participants, if you would have any query or any doubt related to S3, whatever sir has explained, you can raise your query either verbally or by using chat box. It will show your active participation. Up to now, only one response has come. So participants, are you there?
Yeah, actually, I want to make it more interactive, but this is more little bit theory. But yeah, we can spend some rest of the time playing around the data. So I highly recommend people go create your S3 bucket, play around it, whatever the concepts I went through. I think those are the key concepts that I covered. Most of the important concepts I have been covered. And I will also share the presentation with Naveen and he can circulate the presentation. But all the data, this presentation may have some old information, but you need to keep on watching the AWS website to have the latest information.
Participant, you give your response in terms of yes or no. Okay. It would be better for us to know that whether it is good or not.
Yeah, somebody said we need practice. Yeah. Yeah, so yeah, I say go ahead and log into the S3 bucket. Let us go whatever the concepts we went through. Okay, so main important concepts is what are the operations, how the buckets have been created, and what are the operations you can go and do it, and what are the properties you have, and how the versioning is. You can create the versioning, and how the permissions, what kind of permissions you can give, whether the what kind of public access I can give and what the next main key point is the management access, where the lifecycle policy and replications policy are important. I think these are very rarely used, but if you are very interested or if you are very specific based on your requirement or the department in which you are working, that is one of the key things. But in general, I can say access point is also very important because basically anybody want to host a website, they can go and upload the content or the HTML page or one resume, and then they can make it available and page is available for them. So right now I have created one file where it has been available for the public, and that is this baby photo which I have uploaded just now, and then that is available on the S3 bucket. So I quickly for next 10-15 minutes we can play around, and if you have any questions I can help you out. Then I can go get into the CLI part for other 10 minutes. Is it okay? So I will give a small assignment for everybody. So, and I will say, I will raise a voice and then somebody can showcase me. I want volunteers to be here so that they can share the screen and they can execute the activity, and that way other people also know about it. So anybody from volunteers who want to come and for forefront. Sorry,
अगं मी याच्यासाठी फोन केला होता काहीतरी मुंबईला त्या म्हाडाच्या जागा त्याच्यामध्ये ना तुम्हाला म्हणजे आता
sorry, I am not able to follow. Somebody can help me. Anybody, Vijay Krishna, Lakshmi, or anybody from Rudula, or somebody who can want to share the screen, Anjali Devi, I don't know, like anybody who volunteers who want to share the screen and play around and remaining people can watch, or how do you want to see this one so that you can play for some time, that so that it will help you to make this happen more interactive and wonderful, right? Any volunteers, please, from the audience who want to come forward and share their system and quickly showcase, and I can guide them. So Naveen, can you help anybody or can be volunteered? Let's see this one. How do you see the content of the chart? I don't know. Can you guide me here? Like, what should I click on here to see the what people are typing here? Oh, okay. Speaker thing. Okay, got it. Yeah. So anybody, Prasad Garu or Naveen, Prasad Garu, can you help me to share your screen and we can go there? Yeah. Yeah, I think Prasad Garu is, yeah. So Naveen, can you give control to Prasad Garu where he can share the screen? Hello.
Sure, sir. Sure, sir.
Yeah. Isaac Prasad, right? Dr. P. Isaac Prasad. Yeah. Can you give control to him?
Yes, sir. Yes, sir.
Yeah.
Prasad Garu, sir, can you raise your hand so that I can identify you easily? Sir.
Can again open this one and we can type it there maybe. It is Dr. P. Isaac.
Okay, Dr. P. Isaac.
Yeah.
Okay.
I'm highlighting here, right? Yeah, give me a minute. Okay.
Yes, sir. I change his role.
Yeah, okay.
As a
That's good.
presenter.
Thank you. Yeah. Also, you can unmute him so that he can speak.
Yes, sir. Sure, sir.
So I want volunteers to be participated more interactive. I will want to make the session more interactive, but today it was more theory, but definitely in the next session, I will reduce the theory and try to showcase more in practice that may help and inject more information for you.
Participants, we should use the chat box as much as possible to make it more interactive so that your whatever be your query or dot will be clear. Because I think from my perspective, we will not give such kind of opportunity many more times.
Good morning, sir.
Yeah, thank you, sir. Yeah, please. I request you to share your screen.
Yeah, I'm trying to share my screen, Master.
Yeah, sure, sir.
Yes, please.
Sir, where is video?
Not in this row. Welcome. Switch to this. Can you guide me how to share my screen?
Yeah, you can click on the menu. You have share. There is an option called share.
Menu.
In the menu, yeah, in the file menu, like there is a file edit share, right?
I have done by using my web browser, Master.
Yeah, but I'm saying like you need to first on your on the WebEx meeting, you need to click on share.
Okay.
So you go to the window where you have the WebEx.
Yeah, it is here.
And then in the WebEx, you will find file edit share.
Okay. I have joined my, okay, yeah, file edit share, it is there, yes.
Yeah, when you click on share, then it will show you share the screen, right?
Yeah, share content.
Yeah, share content, and within the content, you will see the screen.
Yeah, screen one is there.
Yeah, you can select the screen one, and your screen is, yeah, it's coming up. Yeah, now you can open the browser. Yeah, you can log into the AWS console.
Yeah.
Yeah,
Now
you
shall
can
I
click on the plus
web
sign.
server?
You can click on the plus sign on the top right, and the next to WhatsApp right, you can click on the plus sign, open a new tab.
Where it is?
All I'm trying to say is in the address bar, go to the AWS console.
No, you want me to log into the Amazon web server?
Yeah, correct. Yeah. So open
That
a
I
new
will do.
browser.
Yeah.
Tab.
Okay, that I will do. Okay,
Yeah.
you are talking about opening a new, okay.
Yeah. You need to share the same screen, I think. So can you click on the tab, please?
Okay, again you want me to share?
No, you are already sharing. All I'm trying to say is open a new tab. Next to your mail, right? Where you have a mailbox open, then you have WhatsApp open.
Yeah.
And next to that, open a new tab.
Yes, I have opened Mashkaru, and I am logging in the web server.
But I am not able to see the console, right? So wherever you open,
1 second, I will come back.
maybe it is in the different screen. I'm not sure.
Yeah, I have logged in from two systems. One is desktop, the other one is laptop.
No. You need to, wherever the screen that you are sharing, in that screen you need to.
There itself, I need to open it. Okay.
Yeah, correct.
Yes.
I want everybody to see this one. Yeah, exactly. Yeah, thank you very much. Yeah. So log in here in the AWS console. Yeah, you can go on the first link. Yeah, that's okay. Thank you very much. So now you can type
My
S3
screen is visible.
on the search bar. You can type S3 there. Okay, and click on the first one, S3 bucket. Very good. Now go and create a bucket. Click on create bucket.
Services, sir?
Yeah, no, you are correct. There is a create bucket, right? On the right hand side, there is an orange color written create bucket.
Yeah.
Yeah, click on create bucket.
Yes, Master.
Yeah, give some name, like a unique name. Yeah. Now come down all the way down. So basically you are creating the US one. So the second parameter in the drop down, can you go a little bit up? Yeah. So it is AWS region. So you can select US East 1. Yeah. And then come down all the way down. Yeah. Little bit scroll down. Yeah. And now click on tags, add a tag.
Can I enable this version?
Yeah, you can enable it. It's up to you. But for now, we will come to that again. Okay.
Okay.
Give your department. Department key as department. No, key as department. No, key value is department. No. What I'm trying to say, key is department and value is mechanical.
Yeah, I understood it.
Yeah. Yeah. And then you can also say, one more tag. You can add one more tag. Add a tag. And say university. And you can give KL. Yeah. And you can come down again, leave it like that. Come down again, and come down a little bit down until you say create bucket. Okay. So now the PIP bucket is already there. You can say mechanical engineering. Say you say ME there, append ME there next to that. I'm saying like PIP bucket ME.
Okay.
Yeah. So basically to make it unique across the board.
Okay.
And you cannot give uppercase. All the cases should be lowercase. And you cannot give underscore also. Underscore is not also allowed.
Okay.
Yeah. Now try it again. One more time you can give it a try.
Here also uppercases are allowed, Master.
That is fine. That is for our reference only. Basically, here the tags are useful when you want to differentiate your files with other files. Basically, this is for accounting purpose. You are for charging, like which department is in what resources. So now you are creating one bucket, and your colleague may be creating one more bucket, right? Within your same department, and you want from your account the university has to charge, right? So during that one, they will distinguish who has created these resources. That will help us.
Okay.
That's the main idea of creating the tags.
Okay. Now I think it is creating.
Yeah. It has created the bucket now. Can you come down a little bit down now?
Yeah, it is here.
Now click on the bucket name. Go inside the bucket. Okay. So now let us go and upload a file there. Okay. Can we upload a file, any sample file only from your desktop? Click on add file. Yeah. Go inside the file, inside a folder. Go inside a folder. Within the folder, you can go inside. Yeah, and select that file. Yeah, select this file. That's fine. Yeah.
No
file.
problem.
Yeah. We can delete the file later again.
Okay.
Yeah. Now come down all the way down, and you can say upload. Now the file size is 40 MB. It may take some time to upload. Okay. Let us wait for some more time. So whenever you are uploading a file, the size of the file can be up to 5 TB. Okay. So in a given bucket, you can upload a file of the size of the 5 TB. Up to 5 TB, you can upload the file. If the size of the file is more than 5 TB, it will have a problem. So in that case, you need to split the file into multiple chunks, less than 5 TB. So when you say here how we calculate the file size, we have MB. So 1 MB is the 10024 bytes, and the 10024 MB is 1 GB. Okay, and the 10024 GB is 1 TB. So into multiple of again you need to say 5 times. So you can go all the way up to 5000 plus GB. 5000 GB becomes 5 TB. So up to 5 TB you can upload the data there.
Yeah.
Okay, now if can you come down a little bit down. Now you have successfully uploaded the file now. Okay.
Yes.
So
Yes.
now if you go and click on the file, now. Okay. So now when you click on the file, now if you see there are properties of the file. Can you come scroll down a little bit down?
Yes.
Yeah. So who is the owner of the file? You got your name, and that's
Yes.
the location. The S3 URI is the location of the file where you are storing the file. And what is the region? The region on the left hand side, the AWS region. So initially, when you are uploading the file, I asked you to select US East once, right? So that's where
Yes.
you are uploading the file here. And then if you come down a little bit down, ARN is the unique identifier. So in AWS world, if you want to identify any particular resource, that resource is identified by ARN. ARN is nothing but Amazon resource name. That's the second property from the top on the right hand
Yes.
side. Yeah, that is the ARN. So this ARN is a unique ARN. Like throughout your any resource that you want to identify within the AWS, using this ARN, I can uniquely identify that particular resource. Okay.
Okay.
Okay, so then you have the object property, object URL. So now if you want to use any third-party API, like the Amazon provides different kind of access permissions, like either you can go with the CLI commands, or you can go with the AWS SDK commands, or you can go with the different API commands. For those commands, if you want to access this particular file, you can use this object URL and access that file again. Okay. So can you come down a little bit down again? Yeah. So now here, if you want to have versioning, now you can click on enable versioning now. Click on enable versioning. Yeah. So now version is enabled, and this particular file has been created a new version. Now if you go and add the same file again, it will create one more version for the same file. Can we do the same file again?
Again, you want me to enter?
Yeah, correct.
Shall I go to buckets?
Yeah, you can go to buckets, and you can say upload file again. You have go inside the bucket. Yeah, now again upload the file, same file again. Yeah, select the same file. Yeah, and say upload. Let us give few minutes so that it is uploading the file.
I have reduced it from 100% to 80% for the better
That's fine.
visibility.
That's fine. That's fine. Yeah. Thank you. Yeah, I recommend the participants also do on the respective computers whatever sir is doing. So that will help you to experience like what is the purpose, and you know the feature. Tomorrow you want to upload the files or you want to do any manipulation of the files, you can play around this particular service. This is one of the beautiful and key services that you can use. So one of the major players that these services are being used is Netflix. So Netflix is the one service in US. They heavily use AWS services. All the videos they play on the S3 bucket, and they provide the video services, and it's like Amazon Prime services in India. So yeah, so they, and then like you have a Dropbox and you have any of the data services where you can store huge amount of data. This is one of the key services you can use. Yeah. Now can you go down again? Yeah, click on the file again, the same file. No, same there only. There you're seeing the file, right? Yeah, click on that file. Yeah, if you go to the version, click on version tab. There is a property, permission, and version, right? Click on version. Yeah. So now if you see, there are two instances of the same file, right? So if you have two versions now, you have two versions automatically created. So for example, you are working the same file today and you modified and you uploaded. Tomorrow you modified again one more time and you uploaded. And the subsequent day you did the same time, and every day you are uploading the data. So each time you upload the data, it will create a version there. So at any given point in time, you want to go back to the previous version. You remember like on so and so day, I have created the so and so file. I want to have the previous version of the file. You can go and download that specific file. Now you can go and select the version. Next to the version, you check, put a check mark there, highlight that one. Yeah. This no, not second one, just the second box, not the on the top. Yeah, just the second box. Now, yeah, you only are selecting that specific version. What are the version you want, and then you can click on download. So there is a download button on the top, right? Yeah, so you can click on the download, and that specific version will be downloaded into your local machine. Okay. Similarly, I can, yeah, you can say cancel for now. Yeah, can you go back to the bucket now again? And create one more bucket. And you can say bucket department 2 or something like ME department 2, KLME department 2, something like that. Yeah, you are correct. You are there. That's fine. That is US East is the one. We are selecting US East only. Yeah. Yeah. Now we click on again, go inside the bucket, department 2 bucket. Yeah. Now I can say upload again. Now click on add folders. Instead of file, you can say add folders. And select a folder. You can select MTech folder. There is a MTech folder, right? You can select one of the folders.
I'll select a folder which is having very little data.
Yeah, that's fine. Yeah.
Give me a second, master. Yeah, it is uploaded, Srinivas.
I was on mute, sorry. Yeah, sir. Thank you very much for the support, sir. I appreciate your demonstration and coming forward. That is really helpful for us. Yeah, I want everybody to practice this one so that you are comfortable and you can play around the different ways. Like you can create a folder, you can delete a folder, you can copy the files from one folder to other folder, and then you can write the queries on the folder, or you can also do the CLI commands from the local to the S3 bucket. How do you copy? So if you go to CLI, maybe in the next session, I will try to find out if you can extend one more session for this one, where you can also create commands from your local to S3 bucket. Okay.
Now, how to see whether our folder is uploaded or not?
Yeah, click on the M2 dep M2, one go up, one level up. You should be able to see the folder, to my knowledge. Can you come down now? Yeah, I think there is a slight difference, but I will figure out. But generally what we do is we create a bucket name, and within the bucket you go and create a bucket, and there you can go and upload. But basically it is creating a metadata saying that in the metadata it's saying as folder.
Okay, so here I need to.
Yeah, next one, next to the name, the folder name is coming up, right?
Yeah, SSP class copy.
Yeah. So basically using that folder, you are copying that file, basically. That's how it is differentiating.
Okay.
But if you are not comfortable with this approach, you can go and create a bucket. Within the bucket, you can go and create one more bucket.
Okay.
For example, now can you go scroll up, little bit scroll up? Yeah, close that one. Status, upload status, close it. Yeah, now say create a folder now.
This
Yeah,
one also
so
I'll close.
you are able to see the folder now, right?
Yeah, here it is.
Yeah. That's what I was saying. Yeah, within the folder you have the correlation.
Yes.
So what I suggest you, sir, is if you go to actions, right? Click on actions. Yeah, so these are all the actions that you can do. You can do a copy, you can do a move, you can do a query on the data. So these are the different actions, or you can download the file. So those are all the things that you can play around, and you can calculate the data, and you can also change the class storage. So if you see now the file that you uploaded, the storage class type is standard. Now you can you go and select that file name on the left and click on action and change, come down and go to edit storage class. Click on edit storage class, right? Yeah, now we can say from the standard, you can change the storage class to some other storage class.
Intelligent data.
Yeah, anything is fine. Click on that and say, click on save. Okay. Yeah, if you come down now, close that one. You just say close on the top. Yeah, now if you see on the right hand, the storage class has been changed.
Yes.
So the advantage of changing the storage class is if it's an infrequent document that you are not accessing frequently, and you want to reduce the cost that you are paying to the Amazon, that's where we are changing the type of the storage class. So if it is an infrequently accessed document and you don't want to pay maximum price for it. So if it is a very document where you 30 days, every 30 days you are going to use, then you go for infrequent. If it's a more even lesser usage, then you go for the next level. And if it's 90 days, you go for glacier type of classification. Yeah, if you go down, so they have mentioned the duration, right? So duration type is 30 days, 90 days, 180 days. So based on the type of accessibility you are doing, if you are accessing within 19 days, go for Glacier. If you are not accessing even within 90 days, you want to very rarely use it, then you go for Glacier Deep Archive.
Yes.
So that is a infrequently accessed data, basically. So the advantage you are having is you are paying very, very peanuts of amount of cost for the document that you are not rarely using, but the documents are still available in the S3. Similarly, I can go, when you go to the bucket level, you can also create the policies.
Shall I close it, Master?
Yeah, you can close it and you can log off.
Let us delete these two.
Yeah, you can delete it, sir. You can go and delete the folder. Delete the content first. Yeah, click on delete. And you need to type delete there, delete permanently in the box. Yeah, now delete objects. Yeah, and close it again. Yeah, you can go one level up. You can click on the bucket name, ME department 2.
Is not
On the top, S3 next to S3. Yeah. Now you can delete the folder also. Similarly, the folder is also gone. You can go one level up, and at the S3 level, you have other folder, right? You can also delete the bucket now. M2 doesn't have anything, right? You can click select and delete the bucket. Click on delete, and you can type delete there. I think you need to give the name of the bucket here.
Yeah, name of the bucket is
The name of the bucket, yeah. Okay, so that way you can access the files, you can delete the files, you can play around the files. Yeah, it will not delete because you need to make the bucket empty first, then only it will allow you to delete. So you can say empty the bucket, click on empty the bucket. Yeah, you can delete. Again type delete. And close it again then. And delete there again. Yeah, I think you need to say empty. I think there is not empty. I think there is one more file there. Can you go there and see?
Only one will.
Yeah, I say click on. Can you go one level up and say? And click on empty bucket.
Oh, this.
Yeah, there is a button called empty. Click on empty. Yeah, click on empty. And say delete permanently. Permanently delete. So here the reason why it is saying not empty, because internally when you go for standard storage, there is a replication process underlyingly happens. So it has other copy of data in other location. Internally that replication policy is done by Amazon S3 service.
Okay. In case of standard storage.
In case of standard storage, correct.
Now it is deleted.
So accidentally, if you delete the server, it has a backup copy. So that's the reason you need to empty the bucket.
Okay.
Yeah. So now you have cleared everything now. Okay.
Yes, sure.
Thank you, sir.
Thank you.
You can log off now. Yeah. So hope this helped you, right?
A lot it helped, Master.
Yeah. So you have any other questions? I request you send out a mail, share with Naveen. Naveen can pass the questions, and maybe I will take a next session where I can help you to understand more in better way. But I will try to make it more interactive session for the next 10 hours. But I want volunteers to come out so that will help the team to understand in better way.
Srinivas garu,
Mhm.
shall I ask one question? I'll take
Yeah,
just only
sure,
1
sure.
minute.
Yeah, no problem. Go ahead.
Actually, my daughter draws the pictures and paintings very innovatively. My intention is to create a website on her own name and keep all her paintings date-wise and number-wise in that website. Can I make use of this Amazon web server for that purpose?
Yes, yes, sir. Yes, yes.
Yeah, now I'm getting some idea to create folders because she will draw all the independence type, freedom fighters, coronavirus paintings, and category wise she is trying. And
Right,
I
right.
can place date wise all the diagrams. She is really a very good artist, doing
Yeah,
7th class. So I
yeah.
wanted to place them and let me put that website into the world so that people can watch it.
Correct, correct, sir. So you can also use the, so we have in what you call in the, if you open a Microsoft normal email account, there is something called Microsoft Drive.
Okay.
Even Microsoft provides a similar kind of feature, but it will not provide you the facility to make it public. That's the only difference. But we can find out if easy. She can open a GitHub account, and in GitHub account, what will happen is they are giving a provisioning of mapping as a website. Okay,
Okay.
so that way you don't need to pay any services. Then you can use the GitHub account, and you can make it public, and all the people can see, and you can just pay for the domain service. That way you can
Okay.
save some money there. Okay.
Okay, Master.
Yeah.
Thanks for your advice.
Yeah. Yeah.
Excuse me, sir. Myself, Ravikumar. I would like to ask one question. May I ask, sir?
Yeah. Sure. 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 Please.
Sir, your explanation and hands-on is very much useful to us, sir, to upgrade ourselves, our skills. Thank you very much. And one more thing, to enter into the industry, basically, what the technologies we need to learn, sir?
So it depends, sir. What is the area of interest and what is the role that you want to play is a very key thing. So what is the role you want to play as an architect, or you want to play as a developer, or you want to play as a system engineer? So Amazon services are very huge. They have multiple
Sir.
certifications.
Sir.
Yeah, you can send me an email, and we can
Sir.
have a one-to-one discussion. Or in the next section, I will also go through different types of certifications. So when you click on AWS certification path, it will show you the
Sir.
different paths of certification. So generally, the first one you should learn is the AWS solution architect, which will give you a maybe 10,000 feet overview of what are the different services and what are the uses of different services and how the industry is using these services. Then again, you can do the professional certification where you can act as a consultant for the enterprise organizations. So I suggest
Sir.
like people who has like say 10 years or 15 years of experience,
Yes, yes.
we can choose for a solution architect kind of role, which is more helpful for you.
Okay. Initially, to enter, it is better to have the solution architect.
Yeah, correct. Yes, sir.
Okay, definitely, sir. We will practice this, sir. Definitely, we will practice whatever the thing you explained today. Right now, it not happened to do it parallelly. We will do it today or tomorrow, and we will upgrade, and we will be in touch with you, sir. Thank you, sir.
Yeah, sure. Yeah. So I want to volunteers to open it and talk so that it will be now.
Yeah, sir. Sir, this
Yeah.
is Dr. Vidya. I have one command, sir. One query, sir.
Sure.
To serve Kafka as a broker, is there any command to connect Kafka broker with the cloud AWS Grass, sir?
Yeah, we have it. I need to see into that because Kafka I was not using recently. It is quite some time I spent time on Kafka, but yeah, I can provide some resources around Kafka, which is it is called Kinesis Streams in AWS.
Okay.
You can type Kinesis Streams in AWS, then it will come there. Okay. Can give me 1 second. Yeah, I placed in the chat window. If you see AWS Kinesis data streams. Are you able to get my link in the chat window? Hello.
Yes, I got it, sir.
Yeah, okay.
Sir.
So, any other questions from the audience, please?
Sir, if possible, please keep your mail ID in the chat box, sir.
Yeah, sure.
Thank you, sir.
Yeah.
Participants, any more query if you have, you can ask to Srinivas Rao sir. Okay. It is a great pleasure. He is among us.
Yeah, so I mean, we don't need to worry. Like you can request more sessions for me, and we can accommodate through the channel. So if you want to detail sessions, we can go in at a lower phase. And I want to ensure that the associates are able to follow and understand what we are trying to do here. And based on that, I want to extend based on the knowledge that you are gaining. You try to apply the features that we are doing here in your day-to-day activity. So that way, you will also learn and you can also start applying the things. So some of the examples or use cases I told you is, so I have in my resume, I want to post on the AWS website and make it a website. So that is the first thing I want everybody to do it. That way, you know, like the advantage or importance. So now in your resume, you are working on AWS, and I want to say I have already worked on AWS, and I also created a website on my name where my resume is available. And you, instead of sending an email for everybody with your resume, you can send the link to them. So that way you are also marketing your skill set to the entire public, saying that this is my URL and I am also utilizing my services not only for the organization, for myself also. So that is the starting point, I can say.
Okay, definitely.
Any other use cases that you can want to think, or any other questions before winding up the session? Anyone has any questions? Yeah, so I think some
So great.
about the blockchain. There is a very good ML. There is ML machine learning data algorithms provided by Amazon Web Services. So I recommend the associate or the professor to utilize the blockchain services from Amazon. So there are a lot of there is a free online training program for ML associates by AWS for free of cost. So I recommend to go register for the service, attend the service and utilize those services. That's a very wonderful services and which are in demand. And I also want to bring up some ML models for the college, where associates can create ML models and play around it.
So, sir, it's me, Naveen, in behalf of KLU and in behalf of all the participants, I want to say something. It's your unique skill which has been proven everywhere, every time. So, although the class was theory, but you have converted this class into an interactive practical session. So lots of thanks to you. You gave your vital time from your busy schedule to make this session interactive and more informative. So I want to thank you again many times, sir, because not only us, our all participants have gained so much knowledge through your excellent presentation skills. You addressed all the participants concerned with appropriate examples. So lots of thanks to you, sir.
Yeah. So the freshers, I'm helping the freshers for getting their jobs. So I have helped many freshers in my career. So if any associates who are completed their engineering studies and who want some guidance in the cloud computing and who want to take the career can reach me out, and definitely I can guide them to different courses online available, and they can go through, and if they have questions they can come back to me and take the help and get into the industry. Okay, thank you, sir. So is Naveen, we can wind up the session.
Yes, sir. Yes, sir. Sure, sir. Sure, sir.
Yeah, thank you very much again. Thanks for all. Have a wonderful day, and I want everybody to utilize the services. Okay, yeah, thank you.
So participants, we will start. We will start the next session from 12. Okay, onward. So have a tea break. It will be a virtual tea break for all of us. Okay, we will again reconnect from 12 a.m. Okay. Right? 15-minute time. Why?
another speaker for the first session because tomorrow Charan will take one session. But it's difficult to finish certain number 10 every day. Very tight. So 1 hour, I don't know what I'll. Sheet. Right. Okay, we can talk later on. Okay.
Good afternoon, participants. Now, the next session is about to be started very soon. And I'm right. Welcome, Stephen Samuel, sir. Welcome again to the world of this FDP. Your effort is immensely very attractive because so much requests have been coming from the participant side about your presentation skill. Okay, so definitely it is very good. So we all people have been getting so much benefits from you. So with your presence and your knowledge, we are getting a lots of knowledge about AWS. Sir, I request you from the KLU side and as well as from the participant side, sir, please you start your session.
So, yes, hello.
Yes, sir.
Good morning, or rather, good afternoon, everyone. Let me share my screen. Just a second. Okay, so I hope my screen is visible. And right, great. Now, if in case the visibility of the screen goes off, sometimes occasionally it happens, or the sound there's a problem, just let me know. Call me, like tell me, or just send me something on the chat. That's also fine.
Sir, I have unmuted all the participants as well. So participant, if you feel such type of stated problem, you can say verbally or by writing down in the chat box.
So if you tell me in the chat also, because I can see the chat. So if a new chat comes up, if a new chat comes up, then I can see it. So I'll respond to you, of course, definitely. There was something we were doing yesterday, and that was how we were actually looking into how we could stop and start Amazon EC2 instances at regular intervals using Lambda. A small example, actually not really, because in this case, it's not a small thing. What we did before, we also did something else with Lambda, with that file uploader. But that also was not bad because it's actually using an S3 bucket. This is one of the storage service provided by Angular. So now when this, for instance, when you can actually stop and start EC2 instances, is like a replacement for a cron job. And if you can, it's all about automation. So you can automate it, you can schedule it, and it's, very helpful. So basically, this is a very simple solution, frankly. Now, AWS actually has something called the AWS Instance Scheduler. That is a more robust solution. But if you want to implement your own, this is the way to what we were doing at the very last before we broke for the day. That's what I'm talking about. So if you want to use the AWS Instance Scheduler, then you're more or less guaranteed a more robust solution. But if you implement your own, this is also fine. It's a little coding is involved though. In this case, we were using some Lambda scripts. As a matter of fact, those scripts are they're in your folder over here. You'll find some Lambda functions. Very simple scripts. We'll come back to it once we see it on the console. So basically what we did was like this. We created a custom IAM policy, right? And first we created the policy and then we matched it to an execution role for a Lambda function. And AWS gives you that functionality on the console. What services do you want to target? Lambda is one of them because Lambda needs those permissions to execute. So you have to explicitly give permissions to, those executable permissions you have to give to your Lambda functions. Then we actually created the Lambda functions, which are actually in your materials folder on GitHub. So two functions are there. One is to stop and one is to stop your EC2 instances that you have targeted. And we target them simply using the instance ID. Then on the console itself, we can actually test them. So that's pretty straightforward. So we were actually, if we go over here, we went to IAM. And while we are talking about it, I just you'll need to actually get the hang of how IAM works. So this is a good opportunity also. So when we talk about policies, we are actually talking about it's a kind of entity. That's when you attach it to an identity or resource. It defines their permissions. Now we can create it to the management console is fine. We can also create it to the AWS CLI. The AWS CLI, of course, you can just simply download and install it on the net on your system. Or AWS API also you can use. There's an API in place which you can call and use it like that. Now these customer managed policies are like standalone policies you administer in your own AWS account. And then you can attach the policies to identities, which mean users like groups and roles. Now a policy that's attached to an identity in IAM is basically what you call an identity-based policy. So that's why IAM over here. Okay. All right. So let's see the policy that we created. We can just take, I think it was. We had two. So you should have the same thing. So it pulls up this, and the description is just like this is the policy. This is actually it. The description should actually be okay. Never mind. It should actually be start and stop because this is a policy that applies to everything else. So anyway, we put in this version over here. This is IAM policy actually, and it's written in normal JSON. And as you can see, it's very simple. JSON is just a way to represent, it's a replacement for XML. So it's a big relief to a lot of developers around the world because XML people find very confusing and cumbersome and clumsy. It's like how HTML is actually there for format, XML is there for content, but JSON does the same thing. So does YAML, but YAML has a hierarchical structure compared to JSON. So JSON is more readable, much more simple. So all it gives you is the version and the effect that it has, the logs that it'll create, okay, and the action that it can take. So that was the policies that we had actually, that was the policy that we created. Then we went into the roles. Now the role that we gave was something like here we are. I am role lambda. So what we did was we attached our policy to this. And as you can see, it's actually absolutely the same. It has to be. Okay. So we attached to, so that was basically, our permissions policy that we attached and we gave it the name. So this is the role that we'll give to our Lambda functions. Basically, this is an execution kind of role that we have given. The same thing we have also done for the other one. Because we have two functions. One is to start the server, one is to stop the server. Same policy, two different roles. Functionality is different though. In a sense, what the Lambda functions actually do. Now, from there, okay, let this load up. So that's fine. All right. From there, we went down to the AWS Lambda console. So this says if I think we might have stopped over here. And then we went to create a function and we said author from scratch. So we gave the function like first one was like something like we have to actually give two. So it was something like start EC two instances. Right. So this is what we did. Now the runtime, because it's written in Python, we have Python 3.9 is available, so that is fine. Then under permissions, we went down and we changed the default execution role. All right. Actually, we changed default. We said use an existing role, and then we chose the role that we had created. And then finally, we went ahead and created the function. Okay. So that was one we created like this, and one was like this. We can take a look. After we actually call create function, then we could add in our code. We got a screen like this with some default code, so we replaced it. Now what you see over here, this is my region. These are two instances. These are my instance IDs. So for your corresponding, take two instances. As a matter of fact, clean up your console, your server environment, because it's a free tier. So don't, have too much stuff hanging around. If you finish with it, then clean it up. You can always build it again. Okay. So clean it up and keep within, I believe it's 30 GB that we are allocated. Let's keep it within that. So this was over there. Once that runs, we have to put in our region, which is US East 2. The region is there. You can easily find it. At the top of your page also, there's, it's over here also. You can see your region from here. Or any of your identity or any of your whatever you use, the URL that you use to connect, that's given over there. So it's all over the place. So what this does actually, it does imports a certain package library, specifies your region, declares an array of instances, and this your EC2 is this is the client that is specified, the name and the region, and it has a certain function. Okay. For EC2 is basically this. It just starts your instances, your instance IDs. It'll start everything that is in this array. And it'll print it out to the console as well. Once that is done, you can simply go ahead and you can, for me actually, just a sec. So come over here, take your instance ID, because the other ones I tried it out and I already terminated those instances. Just come and copy it over here. Does anyone know how I can move this down? But because it's interfering with I can't see my browser properly. How do you actually shift this down? Usually you should. Okay, something like that. That's okay for now. Let's take another one. So you do the same thing. You can just go over here and conveniently copy it, come back over here and paste it. Let's check the region. And it's US East 2. You'll get it from your public IP addresses. So US East 2. Now you need to deploy your changes. Don't forget, because otherwise nothing will actually, otherwise nothing will work. Okay, let us see. Is there anything else settings that we need to do? Runtime settings is okay. Okay, so far so good. All right. Now you repeat these steps for every what do you call it? You repeat these steps for every function you have. Fine. I mean, so then you choose deploy to create another function, just repeat the steps. And now finally we can test it. That is true. Fact is, I don't want to actually start it. Or maybe I'll just, we can. The thing is, it actually takes time. Because when I tested it out, okay, let us just see. We have IOEDA and IO6DF. So let's go and stop the instance. And it stopped. I might have run both Lambda functions simultaneously the last time. So when you select test, it will give you this, your execution result. It takes a little while to actually set up, so that's okay. One minute, the response should not be status is succeeded. Very well, let us go and see the other one, which is actually this is the same thing as you can see over here. Absolutely the same. You make any changes, it should. So yesterday, actually, when I was testing it out, it took an awful long time to stop. Now it's taking an awful long time to start. All right. Let's start it manually. So that's the basic flow for how you can actually simply, create your Lambda functions and test them. So here's the flow. Firstly, you have to create like a custom AWS identity and access management policy and the execution role for your Lambda function. Fine. And then you actually have to associate your Lambda functions with the policy. First, you create the role, you attach the policy to your role. Then you go ahead and you actually create your Lambda functions. All right. Your policy, of course, you can use a JSON policy editor like what we have now. The IAM role also, similarly, you can do the same thing over there. Your Lambda functions itself, you create you have to go back to the AWS Lambda console and create function, choose author from scratch, give it a name, choose your runtime permissions, your execution role, use an existing role, which is what you created, and so on. Okay. So, and that you repeat for every function. So that's why you can see I have two over here, just like how you should have. You should also have two. You should have one for stop EC2 instances, another one for start EC2 instances. Okay. I wonder if it's because I opened it in another tab. All right, here's our instances. Let me go back to my Lambda console. Huh. Let's open it. Okay, according to this has been stopped and the status has succeeded, but it takes time because just to actually stop it yesterday, anyway, this is just an example. You can create a Lambda functions for many different things. So this is just one way of doing it. All right. Now what we'll get into, let's get into what our actual topics for today are supposed to be. And that is, we are going to look at our load balancers. We are going to deal with auto scaling. So we have that, most of that will be done on the console itself. So a lot of today is actually about ELB and auto scaling load balancers, creating an auto scaling group, for instance, connecting it with a load balancer, all that. So that's what today is about. It's all about actually performance and availability, really. So let's just briefly look at what we are actually dealing with. One thing we will, the first thing is all that we have, all the services that Amazon offers, they are to ensure high availability and also fault tolerance in our applications. Okay. And along with that, you have the clustering and you have load balancing along with all that. So let's talk a bit about, just to get some background. I'm sure y'all are all very aware of all this, but let's formalize our concepts before we actually go ahead. So let us talk about, in the context of AWS is of course best. We'll do it in that way. So it's like from a when you take it from a business perspective, this is all about the idea that time is actually money. That's what this is. Time is money. So for every minute that the product is, let's look at it, we'll just talk about it. We're talking about in very general terms. Now we'll get down to specifics shortly. So let's see in the context of AWS architecture, what is high availability versus fault tolerance? Now, for every minute that a product is unable to be created, advertised, or sold, the bottom line will suffer. So this concept is even more important in IT, as we well know. Every minute a system goes down is loss of revenue and productivity. So one statistic I remember is that it's estimated that 98% of companies lose like $100,000 for every hour of downtime. That's a lot of dough. Now with AWS, teams can build very like highly resilient web applications whose downtime is next to never. So I won't get into it again because we all know it very well by now. We talked about global infrastructure, for instance, and how Amazon not only provides that high availability, also reliability. So the chance of failure, even if you go on the Amazon website and see the status of their various data centers, is negligible, less than 1%. And there have been some downtime, but it's hardly likely that multiple regions will go down at the same time. Very likely, hardly likely. And that's what it is. If the data centers are actually spread over multiple regions and you can take advantage of that fact, so you can service customers closer to their location, it's advantageous for you and the chance of failover is less. We saw that in all our, the first couple of days, those discussions. So they just have to make sure basically that their systems are actually highly available or at most fault tolerant. Now, both of which are disaster recovery methods. Now, it takes time and resources to ensure that our systems are sufficiently resilient. So that's why it's critical that a system is either highly available or fault tolerant. They're not actually the same thing. Very often people use it synonymously, but they're not. So either one of the two, but it's critical that they must be characterized by one of the two states. All right, so what is high availability for us? What really is high availability? It means that the system will almost always maintain uptime, even if it's like in a sort of degraded state. Now, with regard to AWS, a system has high availability when it has like 99.99% uptime. This is also known as the 5 nines. So to put that in perspective, the system would be down for something like 5 minutes and 15 seconds in a year. And that is possible and it's actually routine for AWS. Okay, so how do we architect high availability? This is by removing single points of failure by using system redundancy. We have to architect this. We have to think it out. So for instance, if you have 5 computers connected to one server, that's a single point of failure. Now, if that server room flooded and destroyed the server, you're out of luck. Now, to mitigate this situation, however, a backup server can be switched on in case of emergencies. Now, this is what you call redundancy. This is adding redundancy to remove single points of failure. So high availability removes single points of failure by adding redundancy. Now, in pre-AWS days, this was an expensive and a costly situation. No, so businesses actually had to work this out by configuring complex like RAIDs, RAIDs, that ensured this database redundancy. Then hardware would have to be placed in temperature controlled and bomb shelter like center structures. Those were the DRCs, disaster recovery centers. Now, so you can see the abundance of cloud services have made high availability and affordable and like very realistic option for just about any organization. Okay, let's take an example. How we can use AWS to eliminate single points of failure and maximize a system's redundancy. As an interesting note, maybe I had actually worked in a data center, but as a developer, so the data center was there. It took me, wow, it took a couple of hours just to travel to it because the data center itself was out of the city, quite a way out. So a couple of hours every day to travel, 1.5 hours at least to travel there and same to travel back by the fastest vehicle the company had. So it was a huge data center, but just sitting there. So there was space, plenty of space. So the whole team was shifted down over there to work on actually one banking project at that time. So this is how DRCs used to be, but you don't need them anymore. You don't need to buy up land, and I mean it costs capital investment. Your upfront capital investment is huge. So anyway, let's go back to our example. Suppose you got a mobile banking app. And you're in charge of it. Actually, you're in charge of creating it. Now, this app would enable users to do the normal stuff that you do. View their account balance, make transfers, withdraw funds. So optimally, the user should be able to do all of, 3 of these operations all of the time. But in the real world, something will fail, and that is where high availability architecture comes in. So in a highly available system, how do you think it will work in with what we have learned about Amazon's infrastructure? It's quite apparent that the servers for a banking app should span multiple availability zones. Now, within these availability zones, there'll be multiple servers that are configured in the same manner. So what we've been doing, actually, last couple of days, we've been actually creating servers. Our EC2 instances, actually servers on AWS are generally referred to as EC2 instances. So anyway, that way, if one availability zone goes down, the mobile app will point to the other EC2 instances on the backup availability zone. So that's what we are actually going to look at. We are going to configure EC2 instances and make actually subnets also, but they'll be spanning 2 zones at least for our, purposes. So this will eliminate any single point of failure. So what about the user data now? So that needs to be backed up too. So as part of a redundant system, it ensures that the primary database is being replicated on a read-only database in a separate availability zone. And the place where I worked, which I was just talking about, that's what they were doing. It was the largest bank in the country, one of the largest, not the Reserve Bank, but one of the largest. So all that data was actually backed up over there and stored in like this, a read-only state. So if the primary availability zone goes down, then users will be able to at least view their account balances. However, they will be unable to withdraw funds or make transfers, right? You understand why? It's read only. That's because those are write operations. So the backup database should be only set up for read operations. So remember, high availability guarantees essential services. So not full functionality. That is high availability. We tend to think that, oh, highly available means that all of the services, the portfolio of services is available 24/7. No, it's not that. Essential services are available 24/7. That's how it should be. So telling people that once or twice a year they may encounter a situation where they can't deposit a check or they can't actually withdraw money from the ATM for a few hours is not bad. I mean, I get SMS like that all the time from my bank. Doesn't matter. Half the time it's like, late at night to early in the morning. So who cares? So additionally, some of the banking data might not be up to date because a backup database generally will replicate about once a day. It's an operation. Now, what if a higher level of recovery is required? So this is where false fault tolerance comes in. This is where. Now, what is fault tolerance? We discussed high availability. What is actually fault tolerance? It's high availability's older brother. Fault tolerance means that a system will almost always maintain uptime. And users will actually not notice anything different during a primary system outage. Okay. So if high availability was expensive before, fault tolerance was exceedingly expensive. So what's the bare minimum? Multiple servers would have to be load balanced. Databases would have to be consistently replicated. Time-wise, that's a lot of cost in terms of time alone. And availability would have to span multiple regions. So all of this would have to be maintained by the company itself. So not only would the company have to foot the bill for all the hardware and expertise to run it, they would have to follow these, how do you say? Like esoteric, like very like incomprehensible to the layman IT security standards. Now, most non-IT companies simply are not designed to handle this level of complexity. Okay, so AWS steps in, takes care of all these infrastructure requirements, allowing for a fault-tolerant system without having to worry about the hardware. Okay, so we saw how a banking app can be architected for high availability. Let's revisit it and think, how can we re-architect it, say, for fault tolerance? Okay, so picture this scenario. This is the current state. Currently, we have a mobile banking app which has servers. In Amazon AWS terminology, EC2 instances. which are spanning multiple availability zones. The database has a read-only backup that is replicated once a day. This may be good enough for high availability, but fault tolerance sets a higher bar. So instead of having a read-only database in another availability zone, an exact replica of the database would be housed there and possibly replicated to other regions. What does this mean as far as updating operations on the database? What do you actually think this means? It means that every write operation onto the database would essentially have to occur in parallel. Every. That would ensure the database is always up to date. There's no other way. So in a fault tolerant system, every aspect of the production environment state is maintained in a partitioned system. So that way it is always ready in case of a disaster. Now, do you remember we were discussing maybe in the first or second day, first day maybe, SQS. That's part of Amazon's type of messaging, if you like to say. It's actually just SQS, simple queue service. So we could actually implement SQS to our database instead of writing directly to the database. So this is how Amazon provides a solution to this problem. Because normally database operations are executed from a running program or application, right? But the way it could work this way is your API requests. I mean, that's fine. You can build an API that will perform, that will expose a set of endpoints that will allow external applications, once they're authenticated and authorized, of course, to perform CRUD operations against your database. That is fine. So similarly, your API requests would be placed in a queue. All right. So now that will mitigate a couple of threading issues also. So they'll mitigate like possible deadlock because it's in a queue, and also timeouts to the database. Because too many requests sitting at the same time could just, overload your resources. That's very true. Okay. So that would reduce possibility of any single point of failure. So remember that this too will also have to be replicated in a separate environment to adhere to fault tolerance. So, as you can imagine, having a replicated production environment can take significant time and resources to set up and maintain. However, the cost-benefit analysis will be in favor of a fault-tolerant system if the business deems the system is highly critical as far as uptime is concerned. Okay. Just a couple more things before we wrap this section up on availability and tolerance. Just so we get it clear in our minds, the concepts, what we are actually dealing with, and what is the necessity also for us to, use these services on Amazon. So anyway, to bring it down to grassroots, whether or not we utilize high availability over fault tolerance depends on the budget and the importance of the system. So if you're running a big commerce like website, an e-commerce website like Amazon with millions of hits a day, a fault tolerant system is your best bets. And now we all know that internet users are what do you say, finicky, fickle. Now when way back when I was doing some web design, so I was into that. And at that time, I remember that the user, an end user, the average end user would not hang around for more than 9 seconds for a web page to load and stuff, you know. But according to Google now, sites that load within 5 seconds, they have a 70% longer sessions. Okay. So that being said, high availability might not cut it, because once again, high availability is not all your services being available 24/7 all the time. No, no. It is essential services. So high availability in a situation like this might not cut it. So we'll need to actually architect a fault tolerant website. So if the system is running in a degraded state, there's a good chance that you lose customers either way. So you may as well up the budget to like accommodate fault tolerance capabilities. Okay, on the other hand, let's say you are in charge of architecting a website for your employees, but it's not accessible from the internet. It's only accessible from the company's internet. On this side, employees will need to look up data 80% of the time and write to a database 20% of the time. So in a situation like this, high availability would be perfectly acceptable. And finally, in the event that the database server goes down, it would cross over to a read-only database. Now the employees can conduct 80% of their business unhindered until the primary system comes back up. So as mentioned like before, SQS would be useful in this situation. The employees would actually be able to write to the database, but the request would simply take a lag because it's going to be queued until the primary database is back up and running. So they can still perform their work, but they'll just have to wait around, maybe till the next day, who knows. But you understand that if they have to send up a massive load of CRUD transactions, they can do it. It'll just be placed in a queue. And when the primary database is back up and running, it'll be executed. So you just have to wait. So now companies need their employees to maintain productivity, so some amount of disaster recovery is vital. However, it not may be worth the time or money. This is a choice that organizations have to make. It may not be worth the time or money to maintain a level of fault tolerance because the basic expense involved. So that's what we need to know about fault tolerance and high availability. The basic difference between the two, because they're used very synonymously in the software industry. They're not actually. What we will be going into now, we'll be looking at elastic load balancing on very interesting also, by the way. So we will create an elastic load balancer, an ELB. So like I said, just have to get used to it. After a while, it'll become second nature. ELB, elastic load balancer. Oh yeah, okay. Then EC2, elastic compute, lambda, and all these acronyms as applied because there's so much in use. So rather than repeating the term, just may as well let's learn the acronyms. So we'll be implementing an elastic load balancer over here, and there's a number of different types we should understand. So we'll also, there's quite a there's quite a bit of actually stuff that we have to actually, there's a lot of background work we have to do first. For instance, we have to create a virtual private cloud. And we have what you see on the slides over here, these are subnets. So anyway, once we get all that in place, creating the actual load balancer is all right. It doesn't take that much time. So what we have over here is that there's also a number of types. We can try out the classic load balancer initially. Actually, we should develop maybe configure about 2 or 3. So because we will also be using the load balancer a little bit later. We have to have it like pre-configured, ready, so that we can do scaling with it. So we should know how to create an auto scaling group. Now, when we put elastic load balancers together with EC2 auto scaling, that'll be fantastic because that nearly guarantees like over close to 100% uptime, as you'll see. So we'll do that. Anyway, just a couple of things. ELB can actually be public or private. And that depends. If your subnets are public, then your ELB will be public. It depends on how you actually choose your subnets. We will build an ELB that will be public. We'll also have 2 types of our subnets also will be 2 types. We'll have public as well as private. Now the way it works, ELB will be public on our public subnets. That will be internet facing. And the other stuff, like suppose we have a database, you can keep it on a private subnet and let it, so for security reasons, in the same way you can keep your web servers, your Apache web servers you can keep on your private subnets. So for our public subnets, we'll actually need to create something called an internet gateway. And for our private, whatever, like suppose you have databases, maybe S3, but today we won't be doing that. We'll configure EC2 instances with Apache to serve up some stuff. Okay, that's what we can plan that way. So instances that are residing on the private subnet will need something called a NAT gateway. Amazon NAT gateway. What the NAT gateway does is it adds it's like a forward proxy. So if our database or our web server needs to communicate with the outside world, with the internet, it goes through the NAT gateway and then the load balancer takes over from there. Right? So that's basically on those lines, that's how I'll go. This is our basic architecture. We'll talk some more after about this, and then we'll get into our management console and we will we will create our first load balancer. But before that, we actually need to create a virtual private cloud and a subnets. We have to have that in place, and then we have to have all that. That's a prerequisite. Then we can go ahead with configuring our load balancer. So I believe it's time for lunch now. So I will see you all back then at 2 o'clock. Okay. All right. So please go for lunch and we'll meet again at 2, far as I know, the normal time.
We all are observing, sir, how much you are time punctual, sir. We are assessing. We should have such kind of time management policies, sir. Definitely. So participants, now it's time for the break. We all will meet again at 2 p.m. I hope so.
Okay. See you all at 2 then.
Dear participants, now be ready. Dear participants, be ready to join. Be ready to join in the third session. We all should have ready with the login so that we will be very promptive. We will be very prompt and as well as interactive with the Steven sir, because now we are entering into the world of load balancer and auto scaling as as spoken by Steven sir in the previous session. That I think in this session he is going to take the session on load balancer as well as in auto scaling. So, all participants be ready with all the uh, settings. Steven sir. Steven sir.
Yes, I'm here.
Okay, sir. So now
So
I
let
cordially invite
us.
you. Just initiate this session.
I'm getting some kind of echo.
Yes, sir.
I think let me just log in and log out. I mean, log out and log in again. Okay, give me a minute. Yes. So hello. I hope I'm audible. It's better at least. I can't get any echo. Hello.
Sir. Steven sir. Steven sir.
I think I need the permissions for the to share as a presenter.
Yes, sir. Yes, sir. Why not? Why not? Sure, sir. Sorry.
No, no. I just logged in again, but it's as a guest kind of thing. So maybe that's why.
Yes, sir. Now.
Now it's fine.
Yes,
Thank
sir.
you.
So, sir, as a we are assuming that no sound, echo sound is coming right now.
Yes. So where were we? We were at load balancing. So we just do, this is basically what we need to do to set up. Basically, whatever, this is what we need to do to get set up before we start actually configuring anything, right? So let's take a look at what we actually need to do. And these are Amazon AWS recommended practices in any case. So now with elastic load balancing, as we were discussing, they can be public or private. That's fine. Just so you know. So, but we will create it in our public. We will create it in our public subnet. So what we need to do is we have to actually create a virtual private cloud. And then we'll need to create two subnets. Actually, we'll have to create 4 instances, as you can see over here. All right. So what's recommended is that our load balancer should be in our public uh, subnet. Stuff like our web servers, our databases, you know, S3, all that. They can be in the private subnet. Now, within a virtual VPC, all instances can actually talk to each other, irrespective of the subnet. That is how it works. Now, it's highly recommended. Actually, this is what we will do. We will choose 2 availability zones, and the ELB will actually be built on those 2. Actually, the subnets will be in 2 different availability zones. That's how it'll work. Now, the traffic actually between these 2 availability zones is just simply a round robin, nothing else. The traffic itself, when the request comes in, it will go to the first availability AZ1, say. Then the next request will go to AZ2, and the third will go to AZ1, and the fourth will go to AZ2, and so on. However, within an availability zone, the instance which has the least number of open connections will get the next request. Now, for the elastic load balancer should always be accessed using DNS or domain naming system for security reasons. You don't want to expose your IP to the world. So, in a production environment, we should always use DNS to check, to access rather the ELB. Now the health check, so the ELB has a health check because of the instances it contains. So you can set, we have options in which to set. We can also configure our own. For instance, if we're deploying a web server, we can deploy a certain page that will give us, some statistics regarding the health status. But it has, in any case, it can check it also. The default is about 5 minutes. You can bring it down to 30. Then you're pretty sure that your instances are always healthy. So your health checks are related to the instances that are in your elastic load balancer. So this is how it will be. Here's that 3-prong right at the top with the blue arrow. That's actually the symbol for your elastic load balancer. You have a public subnet, you got a private subnet, and as you can see in this fashion, they're spanning 2 availability zones. In the public, you basically, you'll just have, you don't want to have too much internet facing. Most of your stuff, your web servers and your databases, etc., will be in your private subnet. Okay. All right. So let's go back to So firstly, we'll need to actually set up our VPC. Let's come here. So we'll create a VPC and we'll create our subnets, and then we will come to our load balancer finally. So we have stuff to do. And this is a little bit involved. So you have to take it carefully. This is when you configure this, you have to be careful because stuff can happen. So let me choose something, change the region where I don't have any instances as yet. Okay. So I'm basically in the Oregon region. I don't think anything is here. Okay, great. You can do the same. Otherwise, you choose something, whatever your default is. I think mine was like US East. Choose any of these. The first, you have 4 over here. You can choose any of them. Okay. So now we go to services. And for under networking and content delivery, we got VPC. Let's choose that. Okay, so here we are in our VPC dashboard. We can see how it looks. It's like this. Fine. This is our virtual private cloud. At the moment, we have one VPC. This is not what we created. This is what is given by default. For every region, you'll have your own default VPC. So, all right. So let us go and let us create a VPC. Over here, we'll give it a name. Just call it my VPC for now. This is our virtual private cloud. And as it says over there at the top, that's a short statement. It's an isolated portion of the AWS cloud populated by AWS objects such as Amazon EC2 instances, which are basically our servers. Now this IP4 CIDR block, you can put something like 10.0.0.0 slash 26. Tenancy you leave as it is like that. Now you know about this, how this actually runs. It's actually a block for these addresses. It sounds something like this. Like I just put 10.0.0.0 slash 26. Basically, what it translates into is something like this. You start at this. They're taking a range, and this is how they perform their calculations internally. So it's something like 2 so 32 minus 26, because I specified 26 over there. Okay, so that will give me something like 2 to the power of 2 to the power of 6. And of course, that will give me 64. So what it translates into finally is that the range that can be supported is like this. And occasionally, if you make a mistake, sometimes it doesn't matter that much. If you make a mistake, because we have different, we have to set this IPv4 blocks, not on all our components over here in our cloud. So this is originally, this is how it's actually calculated. We have to be a little careful when we're setting it. Anyway, so our initial one, we can just keep as that. Tenancy, you just leave as default. And this is okay. We should actually keep some tags because it's easy to, you can identify your objects easily when you have these tags. So we should actually keep it. Make a practice of keeping it. Okay, so now we can simply go ahead and create our VPC. So our VPC is set and it's actually available already. This has been associated with it. Okay. So the top one is our default VPC. Okay. This is the one we just made. State is available. Okay. Now we can go ahead and create a subnet. You see these are all default subnets right here. Right? There's no name also. These are they came with your territory. They came with your region. Actually, once you came in over here. Okay, so let's create our first subnet. We select our VPC from here, which is my VPC. And the first one that we'll make a private subnet. We can simply call it private A. Our availability zone now. Let's see what we have. We can take, we have 2A, 2B, 2C, 2D. Okay. Okay, that's fine. So we assign that to US West to A. And this will be 10.0. So we keep that as 26. Okay, so you see what we are doing now. I forgot. That will be 28. So because we are making 4 subnets, so I'm just our calculations have to be in order. So you see what we are doing now. To create a subnet, you come and you create your VPC first, your virtual private cloud, and then okay, give it a name, of course. Choose your availability zone. All right, then that's basically it. That's basically it. Now we can go ahead and we can create our subnet. So this is available. These are how many are left, how many IPv4 addresses are actually available for us. At the moment. Okay. Now we have to do this 4 times. So create your associate your VPC. Let's create all our private subnets first. No, private that we had already had. Our availability zone. Okay. Let's put that in. This should be something like this. 10.0.0. This will be 16. And the previous one was 28, so 28. And leave the tags as it is. It's good for us to, that way we can identify it in the list. So 10, 0, 0, 16, 28. And, excuse me. 10.0. There's 4. 10.0.0.16. Okay, now it's fine. Okay, so we got a private one set up. Let's go ahead and create a public. Select our virtual private cloud. Here's public. We had A, then we had B. Okay, this is fine. We can do the naming convention also. Availability zone will be US West to C. Okay, we we have 4. That's fine also. So this would be our last one was 6016, right? Our two privates were 10.0.0.0, then 10.0.0.6. So this should be 32. 32. No, let us change it. Let us put basically it's like corresponding positions, you know, like containers. So the our first private one went into US West 2A, and a second private one went into US West 2B. So those are two availability zones. So our first public one can similarly go into US West 2A, and yeah, that will work. Because they have to straddle, you understand? They actually, the subnets are actually straddling these availability zones. Yeah, that'll be fine. Okay, and we create a subnet. Okay. So we got private A, which is in the availability zone. Where is it? Ah, yeah. US West 2A. Public C, which is in the availability zone. US West 2A. Private B, which is in the availability zone. US West 2A. Fine. All right. So now we create our last public. And this will be this should be 28. Let's check once. We have public B over here. It's in. Oh, thank you, doctor. Yeah, exactly. That should be 28. That's right. Thank you. That's 48/28. Yeah, that's right. Okay. So I think we're all set. Let's create a subnet. Take one look at it first. There's a private US West 2A. That says 00028. $32.28. Let's check that. $16.28. What? Okay. So that's good enough. Then we have US West 2B, 2B. And what else? We have two A. All right. So now we go to we go and we create our route tables. Let's take a look at our route tables. Here's our route tables. They don't belong to us. They belong to this. They're set there by default. So we create our own route table. You can see this over here, main. Okay. So what we need to do is
Hello.
yeah, say.
Hello.
All right, now we should this has 0 subnets. We can attach our subnets to this particular one. I'm just curious why we have 2 defaults over here, because generally speaking, you should have 1. Generally speaking. Anyway, let's see what the details are. It is because we need a main route table. There's no subnet associations, no edge nature. And this is already main. Okay, we can just call it public RT. So we are, because we need a main, you can see that these are main. What we create actually by default is not main. So we'll just use this. Great. Now you can see explicit subnet associations, there's nothing. We have to fix that. Okay. Now we can go ahead. Now that we have this in place, we can actually go ahead and we can we can create our route tables. Let's see the details for our public route table. This public route table actually holds the associations. What it does is that we attach our subnets to this. So this we are keeping for all our public routes. So we'll attach subnets to this first. And right now you can see there's no explicit subnet associations. Okay. Now we have a public one, which has to be main. That is good. Let's create another route table. And this one we'll call private. You'll see why. A VPC, of course, you know what we are going to select. And that's basically it. Keep our tags, because otherwise there'll be like the list you saw before. There won't be any name, and you know, they are all, some of the IDs and everything, like your instances auto-generated. They're difficult to know which is which. Then we create our route table. Okay, so here's our route tables. So here we have our private route table, and now we got a public route table. Now look at this. It's not a main. It doesn't have to be anyway. A public RT, we actually took an existing one and simply renamed it as you saw me do. So you do the same thing. Name it whatever you like, as long as you understand your naming scheme. Name it whatever you like, just so that you know you understand like what is what. So this is fine. So we've got a public route table, which is a main, which it has to be on the main. Private is fine. That doesn't matter. And as still we have no subnets as yet. So let's take a private RT. I'll move this up so we can see something. We look at our subnet associations over here. There are no explicit subnet associations. This is what is available at the moment. Okay. So we can now we can choose from here. Of course, you probably guessed by now that we have, this is a private route table. So we are going to basically add our private subnets to it, right? So we can go ahead and do that. And you can see here's a private. We take our private. You can see that initially all of them were associated with a public RT because that's under main, right? That's our default. So we are taking our two private subnets. And remember that each of these, they actually lie in two different availability zones. That's how we created them. And now we can simply save the associations. And now we got two subnets over here, a subnet associations. Here's our subnets. And these are now explicit. We do the same thing now for our public route table. So we can select that over here. And then we can come down and come down to subnet associations. You can see that just two left. These are actually our public ones, public C, public D, public C, public B, as that's how we, our naming convention. So we can edit it. So we take public C. What we are doing is creating an explicit association now. Okay. So before they belong to, now look, a private subnet over here now belongs to a private route table. Then a private B also belongs to a private route table. It's changed over from main. Now we take our main over here, and once we set that up, now we can save the association. Okay, so we got our two subnets set up with the according explicitly associated with our route table. We have one route table which is private and for basically our private subnets, and another one which is public for our public subnets. Okay, so I think that that is in order by now. And then let us just see my VPC. My VPC is on both. Our route table. This is our default, so never mind. Our public, as you can see, is under main. That's good. So I think that is our route tables and our subnets and our virtual private cloud so far have been set up. Okay. So next we have all this in place, but now how do we actually connect? So we set up everything. How do we actually connect? Like how do we take a public subnet? Our instances are going to reside over here. So how are we going to let it connect, to the net? We need an internet gateway. Okay, so we will go ahead and we'll create our internet gateway. So here is our internet gateway. So our internet gateway is basically for, our instances which like, in the public domain, you can say, basically our public subnet. So that's where it'll reside. So here's one, as you can see, that's by default. So now you can go ahead and we can, let's create our internet gateway. So as it says, an internet gateway is a virtual router that connects a VPC to the internet. To create a new internet gateway, specify the name for the gateway below. So realistically, all we need to do to create it is actually give it a name. So let's call it my IGW. And that's that. We have our internet gateway. Once we click on create. Okay. So now we can attach it to our virtual private cloud. So we go and attach it to our virtual private cloud. And this is it over here. And we attach our internet. So our gateway is now attached to our virtual private cloud. Great. Okay. So now we are going to go back to our route table. And we'll see why. Let's take our public route table. So you see, we don't have any routes as such. Nothing we have over here. All we got is actually our local target. Of course, the status is active and all that. That's fine. But we don't have any routes. So, all right. So let us go and edit our routes. And we'll add a route. And this is basically our first one. Okay. Because it's over here, we simply type in, we named it IGWA, no? IGW. Ah. It was capital IGW.
Sir, simply internet, if we will write, then it will work, sir. Internet.
We need the gateway. My ILG. What is that? It. This is the problem. 1 minute. That's right. Thank you. My IGW. Oh, sometimes. All right. Fine. So if I select it, actually this should come. Okay, now where were we? All right, we go back to our route tables. Okay. We choose a public route. Go to routes. Edit routes. We'll add a route. This will be fine. And it's my. No, this is the mystery.
Samuel sir, it's Naveen. After any time, I found that if we select internet gateway, then I think that name may come up, sir.
Okay, very funny. Oh my God, you're so correct. Thank you. Otherwise, it's supposed to pop up, no? Otherwise, we have to copy and keep the ID with us. It's supposed to be. We just created it. Actually, the name is given as my IGW. It didn't pick it up. Okay, thank you. That's good. Sometimes these things happen. So now this is actually the basically, the identifier for it. Now, okay. Now it's all right. Still surprising that it doesn't pick it up like that. All right, so here we are. We've got this route. Fine. And you see, it's associated with our public RT. So now our public RT is taken care of. Great. So what do we do now for our private RT? If we look at a private RT, we'll see that same thing. We don't have any routes as such over here. So we'll go and we will create what we call a NAT gateway now. So a NAT gateway, we can keep, for instance, internet facing components in our architecture, we can keep in the private route table, sorry, public route table. But whatever we have, like even web servers, we can keep in a private. Well, how do they communicate with the internet? They do it through the NAT gateway, which is what we are going to create now. Now, what the NAT gateway does, it it sort of acts like a forward proxy. So it proxies requests to and forth. So that's why whatever's on your private subnets, they can receive information from outside. Okay, we can create a NAT gateway now. You can call it my NAT gateway also. We can simply choose one of the private ones. Okay, so give it a name. That's always good. The NAT gateway will be created on one of our private subnets. Connectivity type will be, of course, will be public. The elastic IP, we can just have it allocated to us. So that should take care of that. Right. So this is a way for like our servers and stuff which are residing on a private subnets to actually um be able to communicate with the internet, basically with the outside. Okay, there's nothing else to be done on a gateway. That should be. Anyway, make sure I don't select private. Doesn't make sense. If you do, now we can just go ahead and create our NAT gateway. So here's a connectivity type. Okay, status is pending. This is all the monitoring information that we get. Packets out to destination, packets out to source, blah, blah, bytes out, bytes in, and all that. Okay, so our NAT gateway was created successfully. Let us go and see. Okay, state is created. It's going to take a little while to be activated. Okay. Anyway, it's got allocated to the correct VPC. Da, da, da. Right. Let's go back to our route tables. Now, select, say, our private RT. Okay. Now we have our routes over here. And you see we have nothing over here. Okay, so now we are going to actually get some. We're going to add our route. This will just be 0.0.0.0/0. That's right. That's right. And here, hopefully it will come up. So you were right, sir. Sorry, I didn't catch your name.
Yes,
But
sir.
you're
Naveen,
right.
Naveen, sir. Sir, don't say
Naveen,
sir.
okay.
We are brothers, sir.
You were right. Because otherwise it's, oof, I didn't notice that before. So now we've added our gateway. So this is a way for, we already added our subnets, you know that. All our private subnets we already added to a private route table. That's in place. So for them to communicate actually, to have a route, they need a gateway. So this way they will actually communicate. Via the NAT gateway, they will communicate with our load. Okay, so that's that. We have our NAT gateway in place. So via that, basically, it goes through to the internet gateway. Now, a couple more things we should do. Select a public. Okay, no, this is done. Go back to our subnets. Okay, let's take public. Let's deal with our public first. So we have two public. We have public C, public B. Come down over here. Select this over here. So you can, how did that get selected? Okay. First, we'll deal with our public. So we have public C. Okay, let's keep that visible at all times. Come to your actions, go to modify auto assign IP settings. Okay. And then you click on this. This is important. So you should have, this must be enabled. So the public addresses, IP addresses must be enabled for a public subnet. Okay, so let us save that. And we do that for the others also. Okay, so you see what we're doing, right? You can filter it if like having too much over there is bothering you. Oops. Then let's just keep to what we have. Okay, so which one was left? We have private. So we've auto assigned our VPs to, no, sorry, not VPs, our subnets we've got. Okay, we have to do something for our virtual private cloud also. So just click on that and choose our virtual private cloud. Let's just look at everything over here, what we have. Okay, fine. And click on edit DNS resolution. It's already enabled, that's fine. Just checking. That should be there. Anyway, leave it selected. We have something else to do. This property should be set to enable also. This is your edit DNS host names. Your data, because domain naming service, right? The domain naming system. So that this needs to be enabled. Okay. As it says here, it indicates whether instances with public IP addresses will get a corresponding public DNS host names. Okay. So with this, we have actually done all our background work, frankly speaking. So before we can think about creating our load balancer and stuff, we have to get up a virtual private cloud set. Then we need a subnet, and also, as we saw before, we need subnets within different availability zones to launch the ELB, our Elastic Load Balancer. Our ELB, of course, is public. That's fine. So you see, this is what we've been actually setting up. This is what we've actually been setting up over here in this section. And these are our prerequisites. Now we can go ahead and actually start. Now we have that in place. Now we can actually go ahead and start to do the work on our Elastic Load Balancer. Okay, so let us start with that. Now we have our subnets, we have our virtual private cloud, etc., but we have we don't have any instances. Huh? Nothing is there. There's no instances at all over there. Right? So of course, you know what's coming next. We'll go and let us go back. We'll come up to go to your services, go to EC2. Let's see our dashboard. We got no instances. In any case, we switched our region, right? Okay, so let us launch our instance as we've done before. Now, neither do we have any AMIs. Take our Linux 2. So we choose instant type, of course. We choose and then we set on, let's see what we have to do for our networking. So here's our network. Over here, we have to do our stuff. So we assign this instance to our virtual cloud. Then we take a subnet. We've got private A, public C, private B, and it gives us a list. All right. So private A, US West 2A, that's fine. The rest we don't need to concern ourselves about. Really. Okay, then regarding our storage, this is okay. Let's add our tags, actually. Because it'll give it, if you just type in name, oh, and select name, we call it server 1. Take another tag, call it env. And this, just call it anything you like. Configure a security group. Now, same like yesterday, don't do this. See this, it doesn't work. You won't be able to connect to your instance. I don't know what this is actually, but it doesn't work. Okay, so just add a launch wizard 1 is fine. Add a rule. We need a HTTP 8080. That's fine. Okay, review and launch. Security groups, instance details, and we can launch it. We don't have a key pair. We have to create a new key pair. Okay. Uh-huh. So now we can launch our instance and you'll can go for a tea break. And this is a good time because actually we have to create 4 more. We have to create 4 more instances. But anyway, by the time I'll come back, this, as you can see, this takes time. So by the time you'll come back, this should be ready. Then uh, we'll create a few more. Okay, so please go for tea, take your break, and I shall we'll meet back up at 3:30.
I don't know, sir, how you manage the time. So participants, now there is a 15-minute tea break. Again, the next session will be started from 3:30 onward.
Okay, so let us continue then. We have a little bit more to do on this. Okay, so now actually there's a way where we could actually launch one like this itself, but let's see, let's make one more. So we select the normal, choose our instant type, go to networking. Once again, we choose VPC. And this time we are taking a private, I believe. So this should be US West 2A. That's okay. Just a second, I need to check something. Okay, so the first one we did was the okay. Select when I instant type. Okay, they both have to be in actually two different availability zones. This is going to be in our private. These are servers which are residing on a private subnet. So two different servers. One is A in US West 2A. That's the first one we created. The second will be in another availability zone, US West 2B. Okay, that's fine. Our storage, we just take the default. Just keep this as server 2 so we know where we are. Security group, as usual, you know what to do. Just create a new security group. Should be HTTP. This will basically give us access from anywhere. That's okay. Okay, so that's that. Now, after that, we can define our load balancer. But before we do that, let's connect to the server that we already have. So go ahead and connect. All right, so open up your command prompt and just connect. And it's always better to have your permissions file in the same directory. This happens occasionally. Sometimes it resolves itself, but it's still a mystery. So maybe it's still set. There is a lag occasionally. Y'all try and connect. I've got both of these running, so y'all should be try and connect. So has anyone been able to connect? Let me know. Actually, we need to do something. We can keep it for later. That's all right. Very weird. Can't be my net connection. Okay. Like this, I never use anything besides uh okay, give me a few minutes. Let's see how to sort this out. Okay, we'll sort that out later. Let's go ahead and configure our load balancer actually. Oh boy. I'm sure that is the actual name of the file. I should have renamed it. I shouldn't have left it like this. Okay. For me in particular, I will have to actually.
Yes.
I'll have to. Uh, it's. This is what is given me. Give me. Let's. I'm sure that was a name. So one sec. One sec. One sec. Okay. I can always try on. Just once. You see, it's giving me ELB demo.pm, but I'm very sure that wasn't it. Because it found a file of the same name. I hadn't named it properly. Okay, no mind. Let us.
Yes.
I'll have
Steven,
to
sir.
create a couple of new instances, but let us. Let's move on. I'll just create the instances and we'll set up everything. Okay, so give me a minute. I'll launch a couple of instances. Okay, just give me a second. So this is private A, US West 2A. Okay, then we have to add storage, add the tags. Okay, I'll just create the other one and then we can move on. This is just so that we can figure out, otherwise it gets confusing. What is what? So now we can go to actually define our load balancer basic configuration. So we can come down right here and we can click on load balancer. Okay. So once you're down over there, you click on create your load balancer. And actually what people like most is the application load balance is a favorite because it's very flexible. A classic load balancer, but you can try this because we have to create a few more, frankly. When we're going to create like an availability group, and then we're going to hook it up to a load balancer. At that time, we can create an application load balancer. So this one, just to see how it works, just so you get some idea, at least a couple of them we should make. And we'll leave this for later when we're, making a availability group. Once we'll hook this up then. So for now, we can take this. It's decent enough. So this is basically like existing applications in the EC2 classic network. So let's take a look at this. Okay. So we just have to give it a name. Just call it something like, say, test ELB. Now it's asking you, where do you want this? So obviously we are going to take my virtual private network. This is for an internal node balancer. You'll be wondering what this is. It's a, never mind. It's actually, what's the point? You know, we are actually getting creating a load balancer so we can actually manage all the traffic that's coming in from the outside realistically. So the load balancer protocol is fine. Here we have HTTP. This is for the load balancer. This is for the instances also. Right. Now we should look at this. We have to select our subnets. So we have to do this a little carefully. I'm just going a little slow, so whoever's working alongside, they have time to actually see what is going on. So here's our available subnets. So obviously we want our selected subnets. Our private, in any case, we already assigned to a NAT gateway. That is already fine. That is there. So we select one. And then we select the other public one. Okay, so that's what we've named it. We've got our VPC. This we can ignore the default. This is exactly what we need. Nothing more, no less. That's exactly what we need. All right. So now we can click through. All right, now we can assign our security groups. And this one was just made 356, 54, 313, 38. Oh, okay. All right. Actually, the problem being that actually sometimes when you create something, when you finish configuring like your load balancer or your availability group and you configure it wrong, you don't have a chance to edit it. I think that's especially true for the availability group. If your launch configuration is wrong, then you can't edit it after it's created. You have to go back, you have to scrap it and start from again. That's why I'm being a little careful with all this. And you should also be too. But that's okay. I mean, because this is, with this kind of configuration, things can go wrong easily. It's just one simple thing that you might forget or skip. So that is there, but just be careful. Just so that, pay attention to detail basically. Okay, now we can configure um, security groups is done. It's a little warning about our security settings because we're not using HTTPS or any secure socket layer protocol. This is actually a health check, Basically, what it does, it pings it and it checks the response time coming from your instances that are deployed, that are part of your load balancer. So this actually you should think about. For instance, these defaults are all right. Now this ping path, the fact of the matter is, that's why I was asked you all to connect, because we were going to, best thing to do would be to, just like yesterday, we installed Apache web server. So we could install the web server on both instances. And I wanted to show you all how to actually create this an index.html file with a simple message so that we have two servers, two instances. We'll know which one is running and when. We can actually test it out. But we'll do that. But if this is not an option, you can also that is if you have your server configured. So you have a little bit of coding to do to actually, put it on, because we're going through, we have to use a VI editor and this, that. It's not that quick. So TCP also is also fine. Now my EC2 instances. Oh, okay. We'll discuss this later because we haven't really discussed what we're really doing. We're just going ahead and, clicking through, but we need to understand even the different types of load balancers that are available in AWS. You've seen on that screen what you can use. And this is this the load balancing cross zone? How does it actually work? But for now, we can just leave the defaults. Okay. Okay. Now we can click on create, and that will create our load balancer for us. So let's take a look at this. Here's our DNS name. Fine. Here's our instances, which are still, it'll take time. You can see the instance registration is still in progress, but it'll take time. It'll be there at some point. Okay. But it does take time. So if you see an out of service thing, like I've known that it takes quite a bit of time sometimes, but it'll be there. Even this you can ignore. Okay.
In the meanwhile, Steven sir, I have a question.
Yes, sure.
Sir, say suppose that means this has come into my mind right now. Say suppose I have created a VPC. In that VPC,
Yeah.
I have created a private subnet also. What I want to do, I just place a EC2 instance in that private subnet, and now I want to
Mm-hmm.
launch it. So being a private, it will not allow me to launch it directly. So what I have
Right.
to do,
So it's in your private
subnet,
subnet. Yeah.
I have configured a EC2 instance. Now
Mm.
I want to launch it. So being a private subnet, it will not allow me to launch it directly. Is it possible? Means since
Actually, within your subnets,
yes.
whether you they can all your instances can all talk to each other. I mean, it can be launched, and your instances will be able to talk to each other within the subnet.
No, sir. Actually, I want to launch it, and I want that subnet allowed to communicate across the internet.
No, 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 it won't work. That is okay. I understand. That's why.
Yeah.
That's the reason. Because it's
Mm.
private,
Yes.
it won't allow you to. No, it won't allow you to
Uh,
communicate across the
uh,
network if you're in a private subnet. So that's
yes.
the reason why we actually do our subnets and our route table, we attached our NAT gateway.
That's the question, sir. I want to know that. So I am not using the net gateway. Okay.
No,
And if
without a NAT gateway, I doubt very much it won't be unless there's some gap in your security setup. Without the NAT gateway, it won't be able to communicate with the net, with the outside world.
Yeah, I know
That
that
is,
with the help of a net gateway, a private VPC can be can communicate with the internet people. But these notorious questions right now I have received in my mind. How is
okay,
there any way like that? Okay, thank you, sir.
okay, okay. Let's take a few minutes to go through some things about our elastic load balancing, our balancer. All right, because this will gonna take a little time. Don't worry about it unless something's actually wrong. It is say initializing has got a lot of stuff to do, you know, and then it runs a health check also. So where's our load balancer is over here. So you can see it'll come back to healthy after a while also. Unless sometimes things happen, you know, and then you have to redo it. So there's no guarantee that happens also. For instance, once I was making it and all my instances, they came out very strangely. Like for instance, what I mean to say is like take this instance and I mean like take anything. Now you'll be able to see, so look at your DNS address. It's pretty long. It's EC2, this, that, and the other. All that came was like a normal IP address for me, 10.012 or something like that. So it didn't work. I had to create it all again, and then it was fine. So these things happen. So don't get disheartened. Just do it again and just pay a little careful attention to what you're doing, and it's going bound to work. But occasionally, who knows, something happens in the background and this stuff happens. So let's just take a look at what we, as far as elastic load balancers go, what are we basically dealing with? The other thing that we have to do after this is auto scaling. So basically, how we use ASG, which is auto scaling groups, and ELB, which is elastic load balancers, to dynamically, modify, support AWS workloads. Okay, so we've taken a look at this. All right. So we'll talk about this, or we can talk about it now, because that's what we're going to do next. What we are going to do is, like, we have elastic load balancers. We've seen how to set it up. There are easier ways to set it up. They are. We don't have to go through all the pain of actually creating our own virtual private cloud, and then getting our own subnets and all that. We could actually take all the defaults that are already in place, and we could actually push it to work that way. But I wanted you all to go through it, right? All the background stuff that you do if you're going to set it up on your own rather than taking the Amazon default, set it up on your own. So that's why this exercise. So that's what we're doing. That's the first part, the first half where we created our own VPC and then we added the subnets. And then the second part is where we actually created our instances and then we made our, no, the first part was our VPC, then our subnets. Then we also created our route tables, our internet gateway and our NAT gateway, right? Now, if we go and take all the defaults, it can be set up much faster. That is there. And we'll do that like when we, a little later on when we're working with EC2 auto scaling, we'll be creating groups and we'll be combining this with an elastic load balancer to, to actually support AWS workloads. So what this actually means, since is that this combination actually supports the demands put upon our infrastructure while minimizing performance degradation. So you need to understand what does each, why do we combine them? Why do we actually want to combine an ELB with auto scaling? Why don't it just work alone? Okay, so with this in mind, are you're actually just AWS developers, not just a simple end user. You're developers now. So you should have a deep understanding of how to implement these features and what it actually means, what it brings to the table. Now, the main function of an elastic load balancer, which we all know as ELB by now, this is to help manage and control the flow of inbound requests to a group of targets by distributing these requests evenly across the target group. Like you've seen over here, this is a very simplistic in a way. It gets distributed between these two availability zones where we have placed our subnets. All right. And what it does is once it comes to a particular availability zone, the instance with the least number of open connections gets the next request. So this is how that's how the load balancing occurs. Auto scaling is different. It goes well together with load balancing though. Now these targets could be like a whole fleet of EC2 instances or, it could be AWS Lambda functions. It could be a range of IP addresses or containers also. So anyway, the targets defined within an ELB could be situated, actually in our case, it should be, across different availability zones. Now, let's see a typical example. Here's a bunch of users. Right? So we just created a new application and currently is residing on a single EC2 instance within our environment, which is being accessed by a number of users. So at this stage, our architecture can logically be summarized like this, right? Am I right? This is all it is. You got one application, it's on a single EC2, here's your architecture. Now, if anyone, I think all of you are, if you're familiar with like some architectural design and best practices, then you'd realize that using a single instance approach isn't ideal. Although it will certainly work and provide a service to your users. Definitely it'll work. Now, this infrastructure layout will bring some challenges. For example, the one instance where your application is located can fail. Maybe hardware, maybe software, it happens that if it goes down, it'll be unavailable to all your users and you're out of luck. Also, if you experience a sudden spike in traffic, your instance may not be able to handle the additional load based on its performance limitations. So to strengthen the infrastructure to help remedy these challenges, like unpredictable traffic spikes and high availability, and remember our discussion with fault tolerance as well, we should introduce an elastic load balancer and additional instances will be running in our application like this, as you see on the screen. So now this funny looking implement over there, the purple one, that is our AWS ELB. What it basically does is it acts as a point for receiving incoming traffic from users, and then it evenly distributes it, or it tries to, across a greater number of instances. So by default, the ELB is actually is highly available. And why? Because it's an AWS managed service. Now, being an AWS managed service means we don't manage it. So we can actually rest easy knowing that AWS already has all its checks and guards in place. So we don't have to actually worry about the availability of it. Anyway, now it might seem that the ELB is a single point of failure, right? What is the actual difference from here and here? All the traffic is coming through the ELB. Now, if the ELB goes down, what happens? Maybe the diagram is a little misleading, but if you look at it, it's got this circle and it's got like these three like little things, forks pump into it. Frankly, actually, in reality, the the ELB itself is composed of multiple instances, and they are managed by AWS. So maybe that's a little misleading. People, we don't understand that I'm making an ELB. Okay, great. So I think is one thing, one entity. No, in practice, once you configure and create it, it becomes multiple instances in a sense. Like, so over here we got like 3 instances which are like, running our application. Okay. Now let's talk about like how this helps, like the challenges we were just discussing. Now, if any of these 3 instances fail, the ELB will automatically detect the failure based on like, metrics that you have given, those health checks and stuff like that. That also helps. So that's why the health checks are very important in the context of ELB. Now it will divert, like if that's why healthy that we are seeing, this, it'll might, while your instance is being provisioned, okay, and while it's starting up and all that, it'll show like that. It might show for quite some time because it's got a lot of work to do in the background. But if all goes well, the health checks, everything should pass. If all goes well. Anyway, so what happens if any of these three instances fail, the ELB will automatically detect the failure and will divert traffic to the other two healthy instances. Also, if there's a sudden like surge in traffic, now you have three instances rather than one, so they can help with the additional load. Now, one of the advantages of using an ELB is the fact that it's managed by AWS, so by definition, it's elastic. So, what do I mean by that? I mean that it's managed by AWS, so it will automatically scale to meet your incoming traffic as the incoming traffic scales both up and down. Now, suppose you're like a system administrator or maybe, a high-tech DevOps engineer, and you're running your own load balancer yourself. You still have a lot of stuff on your mind. You need to worry about like actually scaling your load balancer and enforcing higher availability. You'd have to take all that into account. Now with an AWS ELB, you can create your load balancer and enable dynamic scaling with just, clicking through some of the screens and configuring it properly. Okay, now we come the types of actually ELBs, or rather more to be more specific, AWS elastic load balancers. So as we saw when we were actually creating it, it gave us a choice, right? There were 4 options, but I said included the third one, which we actually selected, which is a classic. And the application load balancer, which is a hot favorite, we will leave for when we are setting up our groups, our availability groups. Okay, but basically speaking, there are 3 AWS elastic load balancers available. I'd like to talk to you about what they actually do, what's the difference, so you can make an informed choice when you are selecting it. And actually, for practice, just do all of them. This doesn't just for you to get the hang of it. We have firstly, we have the application load balancer, which was the first choice. What this does, it actually provides, as it says on the very flexible feature set for our web applications, whether it's running HTTP or secure protocols like HTTPS. Now, this one is different because it operates at the request level. Okay. It also provides, actually, even based on the application, the type of application that you have, it has features that can ascertain what request should be routed to it. But okay, firstly, it's got advanced routing and all the visibility features which are targeted at application architectures, which basically what it allows you to do is to route traffic to different ports on the same EC2 instance. So you're load balancing on the same instance, actually, you see? So that's pretty advanced if you ask me. And there are ways in which you can configure what to route to different ports on the same instance. It depends. You can set it all up. Then you got the network load balancer, which you saw on the console also. Now this is actually used for ultra high, super high performance for your application. Now while maintaining very low latencies. So that's why it's called network load balancer. Now this, unlike the application load balancer, operates at the request level. This operates at the network level. Sorry, not network. Actually, I can't really say network. Let's say connection. It operates at the connection level. So what it does is it routes traffic to targets within the virtual private cloud. And it's capable of handling like millions of requests per second. Millions. Then, of course, we have the classic load balancer. And of course, they were built in the existing EC2 classic environment, like it says on our console. This operates at both the connection and the request level. The first two are a little more specialized. Take a look at this diagram for a second. And let's go through this. Let's talk a little bit. Let's talk a little bit about the components of an elastic load balancer, AWS elastic load balancer, and some of the principles like behind them. Now, for every load balancer, regardless of the type used, we must configure at least one listener. So the listener defines how your inbound connections are routed to your target groups based on ports and protocols set as conditions. We all know what listers are, really. Now the configurations actually, they differ slightly depending on which ELB has been selected. Then you'll come across this again when we come up to our groups, our availability groups. We have something called target groups. Now, for our ELB, the target group is simply a group of resources that you want your ELB to route requests to, such as a whole load of EC2 instances. So you can configure the ELB with a number of different target groups. And we'll see this when we are setting up our own. We're creating it to be used in along with our availability groups. Okay. So we can configure with a number of different target groups, each associated with a different listener configuration and rules. So what does that mean? It means that you can route traffic to different resources based upon the type of request alone. Just that. Now, what's actually, all right. Now, the rules you've seen. So the rules are actually the rules we saw related to security. But regarding the rules as applied to listeners, they're associated to each listener that we've configured within our ELB. So they help define how an incoming request gets routed to which target group.
But here listener is a port.
It's the listener, yeah, no, not strictly speaking. Actually, what the listener does, it could be also a program or piece of
Yes.
code.
Yes.
Basically, it would take in what it does, it listens to requests.
Yes. That means
So for certain requests, it will, according to the type of request, it will route it differently. That's what it means. Maybe there's a request for maybe information, it'll route it to maybe one particular instance or one port on the same instance. And then a request for something else, a membership option or something like that. So listeners, not strictly speaking, it's not so simple to set up. Your listeners, I mean, of course, you can configure it and all that stuff. But yeah, it has to be configured to actually route. It has to know, firstly, it processes the requests that are coming in, and then it has to know how to route it. It's like that. No, it's not actually a program. I mean, what it actually boils down to, what the lister actually contains is like these rules, realistically. So we can set up the rules. I mean, you can't expect your end users to go hopping into their containers and like we are doing, and start slinging code around. You can't expect that. So based on a set of rules, they can configure rules. Now, okay, it's sort of like this. Our ELB can contain one or more listeners. Now, the listeners can contain one or more rules. Now, each rule can contain like more than one condition, and all conditions in the rule will equal one single action in the end. That's how it is. So, no, you're actually thinking of something else, Naveen, right? Is it?
Yes, sir. Yes, sir. It's Naveen.
Okay, so you're thinking of something else, but in this context, we are actually talking of this. We configure the lister with a set of rules, the rules themselves with conditions,
Uh, Actually,
and all of that will result in an action. It's actually
I
programmatic because in
yes,
the
yes,
end, it translates
yes, yes, yes.
into a program.
Yes. Eventually, it is a program, and
In
why we
eventually, it's going to translate in a program. But for
yes,
the end user's convenience,
yes,
now for a non-programmer, non-developer, it's fine. They'll go to the interface and it's like what you call, we used to call it rules engines. So they can sit over there, they can set up as whatever they want. And whatever they do will be translated into code in the backend. That's fine. So that's basically what it does. So they set up the rules. They have the listers. They can create their own listers if they want. It's associated with rules. They put one or more conditions on the rules, and that each of that will result in an action. That's how it will work. And it's quite neat actually, because it's load balancing means this is how you're setting it up. No doubt, no one said that your load balancing has to be done 50-50 also. You could, depending on the scenario, you could actually 80% of your incoming HTTP requests could be routed to one instance and 20% to the other. That is up to your client. Okay, let's think of an example rule. So look at this, and this would make, I think this would make sense. Huh? If this is your condition, if the source IP is 10.10.1.0/24 and the request method is actually a put, then you forward it to group one, and whichever group one, whatever group one designates. And this is how routing will take place. So load balancing, I didn't say it was not meant to be like 50-50. That's okay. It's according to the requirements, the use cases that you're dealing with. So it's like this. And in the end, of course, it translates into code. So the if statement resembles our conditions. Okay. And the then statement is the action. If all the conditions are met, then this is the action that happens. That's what's going on. So depending on like which listener the request was responded to by the ELB, then a rule based upon a priority listing would be associated containing these conditions and actions. Okay, I'll say that again. It's a little a mouthful. So depending on now listers are configured for particular requests. Okay. For particular types of requests, so maybe source IPs or whatever, originating IP, all that stuff. So a lister is configured. So a particular request will be responded to by one listener, some listener. Now a rule based upon a priority listing, it would be sort of created. It will contain all the conditions and actions that are possible regarding the request. Okay, maybe an example would be better. So we have 10 dot. Okay, suppose the request comes from within the 10.0.1.0/24 network range. Okay, so that's like this condition 1. And once again, is trying to carry an HTTP put request. Now put in REST APIs is mostly it's an update request generally. Even though the actual body of the put request is the same as a post request because it has to transfer everything. If it's updating a record in a database, all the fields it has to send just to update one field, that's a put. Nowadays, I think it's changed a little bit with a little different, so more sophisticated version, but that's basically a put. Now the request, if this case is basically an update request, it would be sent to the target group. If that is basically called group 1. That is your basic action. So that's how it's set up. Just so you understand, this is how the ELB actually responds to requests. Just saying it's a load balancer, the different types of load balancer. How does it work in the context of AWS? How has AWS actually set it up? Now, I been talking, I never ever bothered about it before with all the other stuff we've been doing. But with the ELB, I've been trying to point your attention at the health checks. And that's actually very crucial for an ELB because the ELB associates a health check that is performed against each of the resources defined within the target group. And as we were just talking about, the target group is simply a group of resources that you want to route your ELB to route requests to. So that's why you can have number of different. So as you see, we are dealing with a simple load balancer. We got 2 instances. When you got a whole team of developers working on your elastic load balancer, it could run into hundreds or thousands, and the configuration alone just to set up one your elastic load balancing strategy for your company. Okay, so what these health checks do is to allow the ELB to contact each target using like a specific protocol to receive a response. So if no response is received within set thresholds, then the ELB will mark the target as unhealthy and it will stop sending traffic to the target. Okay. So that is okay. We don't have that much time left, but we're done actually. We will need to continue our configuration tomorrow. But there's just 2 more things I want to mention before we close for the day. We had an option for internal or internet facing ELBs, which we've seen. Y'all have seen doing. So actually, these are two different schemes that can be used for our ELBs. And internet facing, as the name implies, they're accessible via the internet. So they have a public DNS name and that can be resolved to its public IP address. That's why we went into, you know, auto-assigned public IPs and all that stuff that we are doing. This is the reason. Now it also has an internal IP address. So it allows the ELB to actually serve incoming requests from the internet before distributing and routing the traffic to our target groups. Then an internal ELB. You remember that configuration? I pointed it out and it has a little thing over there. What's this? Do you want your ELB to be internal? That option was there. It only has an internal IP address. So in other words, what does that mean? It means that you can only serve requests from within the VP, your virtual private cloud itself. That's how what it is. And but it depends on your particular situation as well. So that will conclude our session for today. Now we did Naveen, we did start a little late today. So I just want to let everyone know that it will be good if possible if we can the time that if we can recover the time that was lost in the morning, because we have a certain number of topics to go through. So I don't want to leave you all short. We should cover everything. Tomorrow is a holiday, so like today we end at 4:46. So Naveen, if you're there,
Sir,
you're
yes,
there,
sir, yes,
right?
sir. I'm here, sir.
So if you can check when tomorrow is a holiday, we can do it the day after also, but we need
Actually,
some extra
sir,
time.
this FDP is this FDP has to follow the AICT norms. So for that, tomorrow is not not a holiday. So dear
Uh-huh.
participants, along with you, sir, tomorrow tomorrow is a session. Okay,
Tomorrow is a
because
session, but
yes,
okay,
sir.
if we can have some extra time,
Ah,
if it's not possible tomorrow, then the day after, if we
sure,
can
sir.
get
Sure,
off
sir.
like,
Sure, sir. Sure, sir. Sure, sir.
okay, so just to let everyone know so that they can make arrangements, at least they'll have some advance warning.
Uh,
You can have it tomorrow or have it, you can let me know in the morning if you want a little extra session, half an hour, 45 minutes.
Sir, it is up to
Problem.
you, sir. It is up to you, and it
Okay.
is based on the demand of the participants. I think whatever you are
Okay.
explaining is very nice, because I know how much it is important for us to know that. But even though,
Things.
sir, nice. If you need some short span of time, of course, sir.
Yes. Okay. So everybody, let's see tomorrow or day after, whatever. We'll take a little extra time because we have stuff to cover and this is necessary for you to have a deeper understanding. You should come out of this training with a deep understanding of whatever we've done, because we're doing a deep dive every day into specific aspects of AWS. So you should know it thoroughly, cover all the topics that are allocated. I don't want to leave anything y'all hanging or like, or like sort of a half knowledge. I don't want that. So we'll see. Okay. I'll ask y'all
Sir,
for extra time tomorrow or day after.
Sir, today I realized that how efficiently you have covered everything inside the load balancing. Because otherwise, each and everything means starting from VPC, subnet, router, association of
Yes,
any gateway take more time, sir. But
it is.
for the entire day,
You
I'm
see, I
observing,
want
sir.
you all
Yes.
to get, a thorough grounding. So that's what I mentioned, that you all must be wondering why is our trainer asking us to go and make VPCs and subnets and create our own gateways. I want you to know that right from to so you're strong in it. And then once you know it, we can go ahead and take the defaults and accept it, and we can finish it quickly. But I want you to know it from the ground up. So that's why we did it from scratch. Actually, what we are doing, we done from scratch. That's how I want you
Yes.
all to understand it.
This shows your, sir. This shows your skill, sir. I realized how I means it's I know it's totally depend upon the individual skill, but how you started the, explaining about the ELB from the BBC level, explaining each and every terms, and then you have reached up to that. So
Yeah.
marvelous, sir,
The thing
marvelous.
is that very often, if I just go and show you all the default, this is a VPC, take the default, and this is a subnet, you won't understand what it actually means. But once you do it from scratch and have to build a subnet and net painstakingly on your own, then you understand what it truly means. Otherwise, it's only terminology for you. You won't get it. You see.
Yes.
So thank you, everyone. I shall see you all tomorrow,
Okay.
and have
Thank
a
you, sir.
nice evening.
Yeah, now it is working.